Hi, everyone. Let's get started. Hello. Yeah. Welcome to Python Types for Fun and Profit. I'm Pradeep. This is Shannon. Where's Gia? OK, he's hiding over there. Gia. So we work at Meta on the Pyre type checker, Meta, Facebook, on the Pyre type checker, which runs on millions of lines of code every day, including Instagram's Python, and helps catch bugs before they land into production. So we wanted to share some of that experience with you. So we've helped a lot of users adopt types in their real-world projects, and thought we'd share some lessons and tools that we have come up with along the way. And just up front, this is not just the three of us. We've also got a lot of contributions from Steven and Alex and Simran. So they'll also be around to help you around during the exercises. So the overall structure is that we have 4 topics. In the first hour, I'll talk about why we need type checking and like how that looks in Python. You'll also spend a bit of time working through exercises right in your browser to get a feel for how types work. Then next, Shannon will talk about how you can set type checking for your project, say in GitHub, in your terminal, and so on. We'll have a short break at midpoint. Then Shannon will talk about number 3, which is typing in the real world, where things get messy. Not everything is cleanly typed. So we have some tools that will help you adopt types in real world projects. So Shannon will talk about that. And finally, in the last hour, Gia will give you a tour of various Python features and how we can use typing for them effectively. Sounds good? All right, so let's begin. What are types? Why do you need type checking? So first of all, Python is already pretty awesome, right? We all love Python. We're here at PyCon. So why do we need this thing called type checking? So first, yeah, let me agree with you. We too love Python, like for many reasons. One of them is clean syntax. We all know that Python has short, readable syntax for things like list comprehensions, f strings, all kinds of features. The ecosystem has a great set of libraries for like whether you like Django or PyTorch or Click or whatever library you like. You have a bunch of them. And then finally, Python is dynamic, which is probably like the biggest selling point for it. You can customize what happens when you look up an attribute, when you call a function, or you instantiate a class. All of that is customizable, right? So Python already comes with a great set of features. However, there are a few pain points that you and I might have run into. Let me give you an example of that. So we'll take a simple code snippet here, a get nickname, where you take a user ID, say a number like 42 or whatever, and you look up the user corresponding to that ID, and then return the nickname for that user. It's a small made-up function, just 4 lines of code. In reality, it could be like hundreds of lines long. I'm just keeping it short for the sake of the example. So upon reading this, you and I might form a mental model of this, saying that this function accepts an integer user ID and returns a string nickname, right? And being good software engineers, we might even write that down in the form of a docstring so that future readers don't have to read the entire code. They can just read the docstring and live by that. So we can think of the docstring as the contract of the function. So as long as the callers satisfy their end of the contract, the function will satisfy its end. So for example, if you have someone calling get nickname with this ID, it's satisfying the fact that the user ID has to be an integer. So the function will return a nickname that is a string. So here it might be Shannon. And if you run the code, you'll get hello, Shannon. Right? So if everybody satisfies the contract, things will go fine. How can things go wrong? For one, the contract that you have could be violated by the caller. We said we wanted an integer, but there's nothing to stop a caller from just calling it with a string. So what if they pass in string 1033? They won't realize it immediately, but if you run the program, you'll get an error saying that you couldn't look up a user ID of type string, right? Or they may just fail to provide any arguments at all, and then that would blow up at runtime too. So what? This is pretty simple code. You might say, just run the code, find the bugs, and fix them within seconds. But in reality, this function might be thousands of lines long. Your program might take 5 minutes to reach the point in the code where it blows up. And that will make your debugging cycle pretty long. Right? We want to get these bugs as quickly as possible. So in a sense, it takes a while to figure out among all your callers which of them are violating your contract. this is the first problem that we have. Another issue is that the contract that you have could be violated by the function implementation itself. So this docstring claims that it returns a string nickname, but is that always true? So you can see that if user is none, it just returns none as the value, which is not a string. So if someone just passes in some ID like 9999, they're adding that to a string, which will blow up at runtime. Again, there's a small function. If it were hundreds of lines long, you would not discover it for maybe minutes, maybe not months, until a user files a bug report against your project. So again, it can take a while to figure out where in your function you're violating the contract in some subtle way. So this was just a simple example, but I hope it gave you a hint of the problems that many of us run into. So you might say, OK, I use unit testing a lot, so that should prevent all these issues. So unit testing is great, and we write a lot of unit tests. We hope everybody does. But one issue is that unit testing usually tests within the contract of the function. So if you're testing for the function that we had, you would check for cases like -1, 0, 1, 999. You would test for various cases, but you probably wouldn't test for things like strings or lists or dictionaries or none, cases like that. In general, we assume that surely no user is going to be crazy enough to send in a dictionary as a user ID. But if you've written enough production code, you've probably seen much stranger things than that. And even with unit test, we may miss branches. So even in top Python projects, statement test coverage usually goes up to like 75 to 90%. There are always going to be gaps in your code where you haven't checked for the contract. And those gaps are probably where errors are going to lurk. And if you say, I'll write great docstrings, yes, docstrings are great. But the problem is that either when you write them, you missed something and your docstring was wrong from the get-go, like ours was, or your docstring was right and the code changed and your docstring became stale, which could be worse than useless because it could mislead users and then cause subtle bugs. All this contributes to make you lack confidence in your code. Because for one, you don't know if you're subtly landing bugs and causing crashes in production, or if you're too afraid of that, you may be hesitant to touch legacy code because you don't know what will break downstream. You may hesitate to make large refactorings across your code base, even though it desperately needs it, because you don't want to risk breaking things. Right? So I hope it's not just me. I hope you've also come across such issues in your code. So let me now talk about how type checking can address these issues. So first, the way you would describe the contract of a function using type annotations is by saying this function accepts an integer. So you say user ID : int. So that means user ID must be of type int. And then you say that it returns a string by saying arrow string. So this is valid Python syntax since Python 3. You don't need a special plugin for this. To a first approximation, you can think of this as basically a comment that is embedded within the code. It usually has no runtime effects. It won't affect the way your code works. But what it will do is help tools analyze your code. Tools like Pyre or MyPy or Pyre, which are type checkers, which use this to check your body. So if we run Pyre on this code, it will tell us that return user returns none, whereas this function claims to return string. It will highlight that spot right away so that you can fix it. So the way you would fix that is by saying this function can return either a string or it can return none. So the type for that is optional string. So optional string means it's either a string or it's a none. And once you do that, you fix that, and then you run Pyre again. It'll tell you that there are no errors because right now everything you return is either a string or it's a none, so your function is valid. So this is how we can solve the first problem of checking our function body against its contract. Second, we needed to check our callers and restrict them from passing in arbitrary nonsense. So if you have a caller such as somebody who's passing in string, you run Pyre, it'll tell you that this function expected an integer and you passed in a string. So it'll warn you right at the call site so that that cannot go any further. Likewise, if somebody fails to pass in arguments, you run Pyre, it'll show you that this function expected an argument. And we also want to make sure people are using the return value of our function correctly. So we saw that we're returning an optional string. Somebody might take the nickname and try to append it to a string. And as we saw, the return value could be a string or it could be none. And Pyre will warn us about that because that could blow up at runtime, and we need to fix our code. So again, this was a simple example, but I hope it showed you some of the ways in which type checking can help you out. So for one, type checking automatically checks all your function bodies and all your callers, no matter how many they are or how long your code is. So you can be guaranteed that your contract is being checked at each point. And because it's automatic, you can catch bugs as you edit. You don't have to wait for minutes for the program to run and then crash and then figure out bugs one by one. You can see all of them at once without running the program. So your debugging cycle basically shrinks, usually on the order of seconds. And more importantly, that gives you confidence in your code. So we talked about silently landing bugs into production. You can be confident that you're not landing bugs of these kinds, like type mismatches. Likewise, you can confidently refactor code or like touch legacy code which needs to be updated because you know that if you break something, Pyre will warn you about it. And if it doesn't, you can generally be confident that there are no errors lurking in your code. So, oops. So my takeaway for you from this sort of short series was type checking lets you have the best of both worlds. You have what you have and what you love about Python. The syntax remains the same. Your code usually doesn't change. It's your function signatures that get type annotations, so you get the same syntax as before. You may not have known this before, but many of your favorite libraries already come with type annotations. So if you use PyTorch, SQL Alchemy, the standard library, all of that already has types for you to take advantage of. And you can keep your dynamic behavior, your decorators, meta classes, all of those, and you can still get the guarantees provided by a static type checker. So I'll pause at this point, ask you if you have any questions, comments, strong opinions. Anybody have any questions about what we've seen so far? No? Also, I was curious. Sorry, go ahead.
I've heard rumblings that like static type checking in Python just isn't feasible or something. Any thoughts?
What do you mean by feasible?
Like it's a territory I'm not familiar with, so I don't really know how to elaborate. But I've heard that. And what is your response?
I would say, yeah. I think the whole tutorial is premised on it being feasible and doable. Yeah.
So it is.
Yeah, it is. Yeah. So if you have any sort of concerns, we can deal with individual concerns. Yeah, I would definitely say it's feasible. Any other questions, comments? Yeah.
Does Pyre work with stubs?
Can you repeat that?
Does Pyre work with stubs?
Yes. Yes. We will mention that when we're talking about the real world messiness. Yeah. Was somebody else out there?
I couldn't hear his question. Could you repeat?
So his question was, does Pyre work with type stubs? So they are one way to sort of inform Pyre about what a library exports. So we'll come to that in the later part of the tutorial. So somebody else? Yeah?
So it's been covered in like part of the tutorial, but yeah, like which type checking system do you recommend, like Pyre or MyPy? I tried MyPy, but
Okay.
I'm not sure what moving this to production kind of looks like.
So in this talk, what we're going to talk about applies to standard type checkers like Pyre, MyPy, Pyrite. So what we see here shouldn't differ among the three. So we can talk about the advantages and disadvantages maybe in a later section. So right now, it's what you see should be applicable to all three. Yeah. Anything else? Yeah. Yeah, and I was also curious, how many of you had a little experience with types, like have used Python types in your code? Okay, a few of you. And how many, like this is the first time you're seeing types or you're learning about types in Python? Okay, yeah, many of you. Also, I have one request, like because you're all wearing masks, it's a bit hard to sort of connect. So I'll ask you if things are clear. So if things are clear, I'll just give me a thumbs up. If not, give me a thumbs down so I can sort of focus on what's not clear. All right? 1 second. So let's say you're convinced that you want to use types in your project and you want to know how. So I'll give you a brief whirlwind tour of the basic features of Python. So functions, classes, lists, variables. So the idea is that if all you take away from this tutorial is just this, you should be able to type check the majority of your Python code. And if you want to do further things like decorators and so on, we'll have that in the rest of the tutorial. So the idea is that for the next 10, 15 minutes, we'll go over some of the theory, and we'll try to make it interactive. We can ask questions. After that, for half an hour, you'll be playing around with Pyre in your browser. So yeah, get ready for that. All right, so we've already seen one example of a typed function. So if you want to have a type parameter like name, you say name : string. It's OK to have default values. You can have prefix : string equals hello. So Pyre will check that. If anybody passes in a name, it is of type string. If somebody passes in a prefix, that's also fine. It should be of type string. If somebody passes in a 1, and if you run Pyre, it will warn you because the name isn't a string, so it'll catch that right away. Likewise, if somebody passes in something unexpected, it'll catch that too. So far, so good. It's like pretty basic. Let's look at star args. So suppose you have a function that accepts any number of arguments, and you want to make sure that all of them are, say, integers or strings. The way you say that is by saying star args : string, which means that every single element of that argument list will be a string. So if somebody calls it with A, B, both of them are strings. So Pyre is happy with that. No complaints. If one of them happens to be a string or something not a string, then Pyre will complain about that, saying that it has to be of type string. Does that seem clear? Yeah. Star quarks are pretty similar. If you want keyword arguments where all of them have to be of type, have to have value of type, say, string or int, you can say star quarks : int. So if I pass in foo equals 1, bar equals 2, that's fine because each keyword argument is given an integer. That's fine. Pyre has no complaints. If I try to do something that is not an integer, Pyre will complain about it. So I'm using integers and strings here, but in reality, that applies to classes as well. We'll see that in a bit. So let's look at our first class. I'll take a simple example of an employee. We have this constructor here. It takes in an ID, takes in a name, and an email address. Now, I want to tell Pyre somehow that I want IDs to be restricted to ints. I want names to be strings, and email addresses could be, say, either string or none. So how would I do that? For a function, the contract is in its function signature. For a class, it's in its constructor. So the way I say that is the same way as for functions. I say ID : int, name : string, and email address is an optional string. So it could be a string or it could be none. So once I've specified this contract, Pyre will make sure that this class is being used correctly, both within its methods and outside this class. So let's see a small example of that. So say I have a method called print email address. So this prints employee's email is self.email address. Should that be valid or not valid? What do you think?
It's invalid due to potentially being none by virtue of being an optional string.
Yep. Can everybody see that? So email address was specified to be an optional string. So Pyre knows that this could have the value none. It need not be a string. So it will warn you about that because this could blow up at runtime. So the idea is that we want to prevent runtime errors, so it will catch these errors upfront. Seem clear? Yeah? Likewise, if somebody is calling a method, say we have a valid method called print name. It prints the employee's name. And say outside this class, I just construct an employee object with some ID, some name, and some email address. And then I call print name with OK. Should that be valid? So does print name accept any extra arguments? It does not accept any extra arguments. So if you run Pyre, it will warn you that this method is not being called properly. So just like it checks functions to check if they're called correctly, it does the same for methods as well. Any questions here? No? OK, I'll move on. What about attributes? So here we have a method called print salary. It prints self.salary. Now, nowhere have we declared that this class has an attribute called salary, which means that if you run this at runtime, it could blow up, right? So Pyre will warn you about that, saying that this class hasn't any declared attribute called salary. The reason is that if you try this in the REPL, if you construct an employee object and call employee.printSalary right away, it will fail, and Pyre doesn't like that, so it will prevent that from happening. And very quickly, I think if you construct an employee and then try to set name to something that is not a string, you can expect that Pyre will complain about that. So it makes sure that your class is being used appropriately no matter where in your code. All right? Yeah, so I think, let me know if anybody has any questions about classes, any lingering doubts. Okay?
I just had a quick question around, is your type annotating like the functions returning none? Is that just like is that standard when you're trying to do type annotations, that if it is truly like returning none, you should say it returns none?
Yes. Yeah. The general practice is that you want to specify the return type so that if somebody calls your function, the type checker will use that return type to realize what the type of that value will be. So it's a good practice to always annotate that. Any other questions? All right. And we'll have a couple more of these, and then we'll go on to the exercises. So bear with me for a bit. So let's look at lists. We have a small snippet called find employees by ID. It accepts a list of employees, it accepts a target ID, and then looks for an employee whose ID matches that target, and then returns it. So we want some way to specify that employees must be a list where all elements are employees. So the way to specify that is by saying, the font is tiny, sorry about that. So we say that it's a list bracket employee. So this is syntax for it. Every element of that list is guaranteed to be an employee. So if you try to use it, so here I'm initializing, say, employees to a list where every element is an employee. I don't need to tell Pyre about this. It can already see that this is a list of employees. So if you ask for the type, Pyre will already tell you that this is of type list employee. So you don't need to change your code for that. And if you try to pass it in, that's a valid input because this function expects a list of employees and you're passing in a list of employees. So Pyre is happy with that. No errors. What about this case? Oops. Yeah, if you have employees where each element is a string, the type of that variable would be list of string. And if you try to pass that in, Pyre will catch that right away. So this is how Pyre checks that lists are being called appropriately. And there are other ways too. So if you have, say, a names variable, which is a list of strings, so every element is a string, so it's a list of strings. If you try to get the length of that, what should the type be? It should be an int, right? So if you're ever curious about what the type of something is going to be, you can always write reveal type of that expression and run Pyre. So it will tell you what it thinks the type is. So here, it already knows that the type is an int. So this is what I meant when I said the standard library already comes with types. So things like lists, dictionaries already have these for you to take advantage of. What happens if you transform a list? So you have a list comprehension here. You have a names, so you go over the names, and then you capitalize and append a string. So what should the resulting type be? So we know it's a list, so what is each element going to be of type? String. Can everybody see that? So if you ask Pyre, it'll tell you that the type is a list of string. So we don't need to sort of tell it about each list that we create. Is it okay to index a list with an integer, which is fine, right? We can always look up an integer index. So Pyre is okay with that, and it'll know that the return type is an int because each element of the list is an int, so a string rather. So it'll tell you that the return type is a string. What if I look up a string? So if I have a names list and I say names of foo, that's going to blow up at runtime, right? So Pyre will warn you saying that this, you can only look up an index, not something like a string, okay? Likewise, if names is a list of string, so you can't just insert arbitrary things into it. So you can't insert an integer. If you do that, Pyre will complain about it. Sounds good? Dictionaries are very similar, so I'll just kind of breeze through it unless you have questions. So suppose you have a function that accepts a dictionary where all the keys are employees and all the values are ages, so ints, let's say. So the way you specify the type of a dictionary like that is dict employee int. Okay, so here, yeah, go ahead.
Maybe getting ahead, but for dictionaries, like, you have like deeply nested JSON and like, it's like, keys a string and values another dictionary, of which that dictionary is string and values being dictionaries and so on and so forth.
Yep.
Is there a good way to get around that without like without having like a type hint that's, 100 characters long?
Yes, so first you can always have nested dictionaries. So that's the long way around. And there are ways to have aliases, if you like. And there are things called recursive aliases where you can say that this dictionary can go arbitrarily deep. So there are more advanced features for that, if you'd like.
So it's like type hint alias, you're saying?
Yes.
Okay.
Yeah. So the question was, can you have nested dictionaries and other sort of shorthand for that? Yeah, there are ways around that. We can discuss that later if you're interested. So yeah, is it clear that you can just use a dict employees to int? So if you ever look at, so we are iterating over the items and getting the keys and values, right? So the key type is known to be of type employee. So if you ask Pyre, it'll tell you that. The value type is known to be int, so Pyre already knows that. What if you had a dictionary like this? What is the type of this dictionary? You can guess. There's no wrong. Yeah, dict from string to int. So all the keys are strings, all the values are int. So if you ask Pyre, it'll tell you it's a dict to string int. So if you look up a string, that's fine. Pyre will allow that. And it could be an arbitrary string, not just one that is known to be in the dictionary. So Pyre doesn't know what the exact contents are. It just accepts any string as a key. So if you look that up, you'll get back a value of type int. Like same as the list thing, you can't. So if you try to look up an integer, that's going to fail, guaranteed, because this dictionary is known to have only strings as keys. So Pyre will warn you about that, prevent you from doing any mischief. Likewise, if you try to assign some non-integer as the value, Pyre will again complain about that. All right, I'm going a bit quickly, but yeah, let me know if anybody has any questions or confusion. Yeah, one more sort of data structure before we move on to the exercises. So we have tuples here. Say this function that returns age, which is hard-coded as 42, and your favorite language is Python. So the way you specify that as a type is tuple with whatever individual types you had. So tuple in words, T-U-P-L-E. You can't just use brackets. You have to say the type is T-U-P-L-E tuple. And because we have two elements, we say we have two types here. The first element is known to be of type int, so we say int. Second element is known to be of type string, so we say that. If you had three, then you would say tuple, int, string, bool, and so on. Okay. So if you try to unpack this tuple or try to look up elements, Pyre knows that the first element is going to be an integer. The second element is going to be a string. What if you try this? This is going to blow up at runtime, right? So Pyre will warn you about that, saying that this is known to be a tuple of two elements, and you're trying to unpack it into four. All right. Yeah, and a quick note about global variables. So in general, you want to help out the type checker by telling it what the type of the global variable is. So if you have something like login counts, you want to tell it that it's going to be a dictionary from user to integer or whatever it is. In general, you don't need to annotate local variables. As I told you, you could see that employees was automatically inferred to be of type list of employees and so on. But in some cases, especially with empty containers, say you have this function which has visited equals empty list. Now, it's a list, sure, but what is it going to be a list of? It could be a list of integers, list of strings. So Pyre needs to know what the type is so that it can prevent incorrect use of that list. So in such cases, you can help Pyre out by giving the variable an annotation, saying visited is a list of nodes, and then the empty list. So this is usually needed when you have empty lists or empty dictionaries, empty sets, and so on. Okay. So quick recap. I know we went through like a lot. So functions, how do you annotate them? You basically look at each parameter, you give it a type, and then you specify the return type as well. Classes, you do the same thing, but for the constructor. So you say ID is an int and so on. And if you have lists and dictionaries and so on, you just say it's a list of employee or dictionary from string to int, and tuple of int to string, and so on. right? Makes sense? Also, I want to give a quick 2-minute example of how Pyre works. But if you're not sort of feeling pretty overwhelmed, we can sort of tune out for a couple of minutes. But I think this might help you to figure out why it does what it does, or like how it does what it does. So let's take this example where we had an error called get nickname, where it returned an optional string, but we only had string. So the way Pyre starts is by assuming that the user ID is going to be of type integer. So it starts out knowing that user ID will be an int. Then it goes on to the next expression. So we come to fetch user. So it needs to check the contract and check whether we are respecting fetch user's contract. So it looks up the type signature for fetch user. Let's say it's something like this. It takes an int and returns an optional user. So at this point, it checks whether the user ID we're passing in is an int, which it is. So that's fine. No problems there. And what is going to be the type of user? So user is being assigned to fetch user of that, right? So what is the type of user? Guesses? What's that? It's an optional user, right? So it's being assigned the value of this function. So the return type is going to be the type of user. So Pyre remembers that as well. So it sort of stores that in its memory. Next, it checks whether user is none. So it goes into that branch. Now Pyre is smart. So it knows that even though user was optional string, that is, it could be optional user, it could be either none or user. Within this branch, because we checked for none, user is only possibly none, right? It cannot be a user. So now when you return user, it realizes that you're returning none, whereas this function expects you to return a string. So that's how it figured out that you were making a mistake at that point. Sounds clear? It doesn't match, so it raises an error at that point. Next, we've returned from that branch and we're going to the other branch. Again, Pyre is smart. It knows that you already checked for none. So what is the only possible type of user in this case? It's only user, right? It can't be none anymore. So Pyre sort of understands that it's only user, and then it needs to look up the nickname attribute. So again, it fetches the user class. Let's say that class has a constructor like this, where nickname is a string. So now Pyre knows that user.nickname is a string, and you're returning that, so that's correct. There's no issue there. So I hope that gave you like a brief idea of how Pyre sort of walks through your code, refining its understanding of what the type of each variable is. Yeah.
How completely does the code base need to have adopted type? So like fetch user.
Yep. Yeah, that's exactly why I wanted to give you this. So you can sort of see where Pyre might fail to check things. So I said it looks up the type signature of fetch user. So what if the user hadn't, the programmer hadn't written any type annotations for fetch user? At that point, Pyre wouldn't know whether it expects an int or a string, so it wouldn't be able to check if you're passing in the right argument. Likewise, what if I didn't annotate user ID? So in that case, Pyre wouldn't know if I'm passing in a string or an int or so on. So that's why you need type annotations, and that's what can happen if you don't add type annotations. Shannon will talk more about that later in the talk. So yeah, go ahead. Yep. Yep.
We have a URL if you want on some sticky notes. If you want to look at them now. But,
Okay. Yep. So, okay. Finally, we're done with theory. Let's do some exercises. We have a series of 6 short exercises where you will play around with Pyre in your browser. We'll start with something simple. The idea is that if you're done, just paste a green sticky to your laptop. If you're stuck or you're feeling confused, just add a red sticky, and one of us will sort of walk around and help you out. Okay. So the playground is basically simple. You just write your code, run check. So that runs Pyre and tells you where there are errors in your code. Okay. So your aim in the first exercise is there's a bug in the code. You need to find it not by sort of understanding it. Just add type annotations, run Pyre, and see if you can find out where the bug is. So go to this URL, short url.at/ps bg9, and then open. So we have a series of exercises. Open it, like the first one in a new tab. open. So can you see a link for simple function? Can everybody see a link for simple function? Anybody not able to find it? Okay, yeah, the first one, simple function. Open in a new tab. Yeah, green means good, red is bad.
Green means you're done.
Okay.
You're done and you're waiting.
Yeah. Yeah. Okay, timer. Time. Okay. So I've listed. Are you able to run?
It is correct that Pyre doesn't auto-detect any function signatures. It has to be explicitly.
Yes. Yeah, you have to annotate function signatures before Pyre checks it. So we saw why, right? It doesn't know what the type signature is, so it doesn't enter that code.
Is there any option to like enable?
There are, yeah. We'll see them later on. Yeah.
Is it? I know we're getting ahead, but is it like not recommended for some reason?
It is recommended. So it's if people don't want to use it, right, it'll be noisy for them. So by default, it's off. But if you want to be strict, you can turn it on to strict mode.
If you add a comment hashtag Pyre-strict on the top of the playground, it'll enable the strict mode.
Okay.
It's hashtag Pyre-strict.
And you can see that in the playground as well. And it'll give you errors for every annotation that's missing. But that can be kind of bad if you like a massive file.
Yeah.
You don't want to get all of it.
Yeah. But then, okay.
Yeah. So we'll see. Things you can do to opt in, opt out, and so on. Okay. I see some green stickers already. Anybody stuck, or are you like still trying out stuff?
So if we enable the thing you just said, then we don't need to annotate anything, right? Because it just automatically.
No. It doesn't know what user ID is, for example. So it sort of.
Tooling that can do that for you.
Yeah.
But we have like inference tooling that can read your code and guess, right? Like there, obviously it does know a lot of things, right? But we'll talk about why we do the like just assume nothing, right? It's kind of a practicality concern for onboarding to big code bases. So talk about that later. But yeah, the type checker itself does not do like interprocedural. Like it won't check your function and then go into a dependency, check that
Done?
function, and then figure it out.
Yes. You don't need to use typing.list. You say. Oh, wait. Is it a list though? So it's meant to be a string, right?
I thought that was incorrect.
Yeah. So you could try different things, but yeah, the intention was that it should be a string. Yeah.
No. I have a resting skeptical.
All right.
Making sure.
Yeah, it looks like most people have finished. So I'll share the solution here. If you're still confused, we can sort of walk around. Do you need some assistance, Simran? Okay. Yeah, I can just show you the solution for the first one. So I hope everybody got that it accepts a string and it returns an integer, right? And the error was where like you passed in a list instead of a string. Yeah, and if you're like super fast and you're finishing the exercises really quickly, feel free to move on. You don't have to wait for me. But if you want to move along with the tutorial class, you can sort of go one by one. All right, let's go to the next one. Same URL. Go to the link where it says multiple functions and open that in a new tab. Simran? Is that done? Okay, yeah.
This is so great. Like, I don't know why. You know, I think I brought up static, or there was some discussion at my work about static
Feasibility.
typing. And it was like, oh, no. Like, it just doesn't work like that. Like,
Yeah.
we can't do that. Like, or maybe I misinterpreted what was said.
Maybe, yeah. You need to tell them about this. Yeah.
I mean, is it really just this easy? Like,
Yeah.
because I'm already big on type hinting. So then that would mean just use this and then
Yeah.
that's it.
Yep.
Well, then why not do it?
Yeah, you should do it. Yeah, we want people to use. That's why we sort of created a tutorial. Yeah.
All these static typing is if you're not going to actually
Run a type checker. Right. So if you're not, even if you're not using a type checker, it serves as documentation. But the idea is you want that documentation to be checked. So it's most useful when you have a tool. Otherwise, you can write something as a string or an int, but then it's actually a list.
I guess what I'm getting at is there's nothing in Python that will enforce any of this that you put in unless you do the static checker.
Yeah, so there's something called a runtime type checker. So this is a static type checker. It doesn't run your code. Runtime type checker checks at runtime whether it is an int. So there are tools that do that for you. They're like bear type, and there are like a few.
But again, not naturally in Python.
Not naturally in Python. Not yet. Not yet. Yeah. So the philosophy is that Python is always, types are always optional. If you want it, add it. But yeah. Yep. That's the philosophy. Yeah. Is everyone sort of done? Anybody stuck? We can move on. Okay. I'll share the solution in case. I think most people are done here. So. Anybody want to share like what is the return type of get name? String. And greet name, what does it accept? String. And returns? None, right? And I hope you all got the error saying that num vowels is an integer, you can't just add it to a string. Okay, so far it was like pretty straightforward. We'll get into slightly more involved exercises from now on. So your first list exercise. So you can go to the third item, which is the lists, and open that, okay?
Just a quick question. I mean, like, is that just the best practice to return none when you're just doing what you're doing? Basically nothing that's gonna ever
Yeah, it's kind of a hygiene thing, but it's also useful when you want to, suppose somebody uses the return type and treats it like a string. You want to prevent that from like somebody who says x equals greet name and then says x dot capitalize. We want to stop that. So in that case, it helps to have that none.
Previous slide both as strings, taking return those strings.
Yes. So you added it as. So what is name expected to be?
Oh, right.
Yep. Okay. And what does it return though?
String?
But it's not returning any value at all, right?
Oh, right now. How do you see it is not correct? Because something here is saying?
Yeah. So can you remove that and make it string again? No, this one. Okay. So can you see that it says on line 17, return type is expected to be string, but then you're implicitly returning none. So it warns you there. So the errors help you sort of figure out what you should do. Looking at the time, right?
You have like 2 minutes.
For this one? Yeah, okay. And if you're done quickly, you might want to experiment. Maybe try adding some code that you're curious about and see what Pyre thinks about it. Like for example, like at the end we have a couple of questions. You can try to answer that. Try using reveal type to see what the type of each expression is.
Yeah, reveal type is that?
It's a statement. It's just a statement that you add. So you say reveal type, and then the expression. So when you run Pyre, it will print the type of that expression. And at runtime, it doesn't do anything.
You have to like import that. I mean, like, what is this? Or is
So yeah, right now it's we're in the process of adding it to typing, but all type checkers sort of treat it as a magic built-in. So yeah, if you run the code, it'll probably blow up right now because it's not a valid thing, but it's useful for debugging your type checking code. So you don't land the code. It's when you're trying to figure out where your program is going wrong. If you're curious, you can just add reveal type and then foo, figure out what it is, and then remove that. So in the future, we adding it to typing. In the official library, so that everybody can just import it and leave it in code if they're lazy.
As of yet, your IDE will likely flag it.
Yeah. Pyre will flag it. Yeah. So yeah, it won't go silently. Yeah. So the idea is you never want to allow people to like have runtime errors as far as possible. The aim is to catch as many of them as you can upfront. Yeah. Shannon, how are we doing on time? Okay. Yeah. Time's up. Did everybody get it, or are you still stuck on a few steps? Gia? I see quite a few green stickers. All right, let's look at. So what did you get for the first function? What does it expect as an argument? List of string. And what does it return? Yeah? So let's look at the doc string, right? So it expects a list of strings, and then it returns a list of strings. Like, did everybody get that? So it's a nested list. Like, if you want, you can just sort of convince yourself by looking at each element. So it's a list where each element is again a list, and the element of that is a string. So it's a list within brackets, list within brackets, string. Any questions or anybody has? What's that? Lowercase list. Yeah. And did everybody get the bug? Right, so the bug is that we're passing in something that is an integer in the middle of a list. So yeah, here's the solution, if anybody still didn't get it. And I hope you tried out like some of the questions below. If you try to reveal type of a variable, you can see what Pyre thinks it is. So you can sort of experiment with that if you like. I'm going to move on to the next exercise unless there are any pressing questions. No? Okay. Yeah, if you're stuck, please add a red sticky so that we know. All right. Our first exercise with classes. Go to the URL for classes. I think it's called simple class.
What is that thing where, like, if you want to type, like, okay, like, I want to annotate the return of the init method of the class. It's like from future import annotations, or is there like?
If you want to make it returns an instance of the same class.
Like on line 9 here, if I want to annotate, it returns talk.
Okay. So yeah, the dunder init it always returns none. But yeah, in case you want to return something of the same class, I think in later versions, I think from 3.10 onwards, you can just use the class. In older versions, you have to use either from future import annotations. Something like that.
You can also quote it. So really, it's just because at runtime that thing is not defined yet,
Yeah.
right? Because it's inside the class you're trying to refer to.
You said
So
you could quote it?
quote it. So you can say like returns like quote talk.
Oh.
And then that way the type checker views that as the same thing, but you don't run into the runtime error of like referring to something that doesn't exist.
Is that Pyre specific?
No, it's standard. So everything here is standard. Yeah, this is like a lot of us have come into these dynamic patterns and like figured out workarounds. trusting you to keep time.
Yeah.
Let me know. Yeah. Oh, yeah.
So for this one, the expected value of none.
Yeah. So greet expects a string to be returned. So that's what it says, expected string. So, but because you're not returned anything, by default, Python means you're returning none.
Okay,
So that's the mismatch.
I see. Okay.
I want one of these. Yeah, I don't have it yet. Yeah, we should give these out that like whoever wins, like whoever finishes first, gets it. I know, yeah. Yeah, we have around 30 seconds left. So. How's it going?
So I've annotated this up here, I think correctly.
Yep, that's it.
I see that this
Yep.
returns none. And then down here, I have a bug talking about how our expected string would have got in. And so here I'm just trying to figure out how to like, this looks like a string to me.
So wait, no, this is on line 22.
Oh.
There are 2 errors.
Oh, okay.
Yeah.
Okay, thanks. Yeah.
Okay, I think I see a lot of people already done with this. So yeah, what do you annotate for the constructor? Title, what do you get for title? String. R is int, and the constructor returns none. And what were the errors? What are the bugs? Line number? Okay. Yeah, you're trying to pass in R as a string. I think that was the error. Was that? Yep. So like input is already defined in the standard library, so it already comes with types. Pyre knows that input returns a string, so that's how it figured out that you could get something wrong. So if you try this at runtime, it'll blow up. Yep. Exercise 5. This is slightly more complicated, so it's okay to take a bit of time on this. It's fine. Oh, it's a bit weirdly formatted. Yeah, we had to increase the font at the last minute. So sorry about that. So it's under multiple classes. So we didn't hand these out at the end? Next section? Okay. Maybe Any questions? Like, I know this is a bit involved compared to the previous exercises. Yeah. Yeah. So yeah, what does it return? String. Yeah, string. You can just try it and ask Pyre. It will tell you. So on line 23. So that's the bug.
I need to fix this.
No, you don't need to. Yeah, you just sort of figured out that so if somebody just uses input and passes in, it's a string which will fail later on. So yeah, it's just to show that you can find out bugs. People are routinely getting confused because of the line number, even though we show the highlighting. They like no line number because there's one error lower down and they're saying I'm looking at this line, I fixed it, but the error still remains. No, it's like because they're not looking at the line number. They're like, yeah. We should probably say. Okay. I'm gonna call time. Is everybody done? Anybody sort of still stuck or need some help? Okay. What did you get for? So did everybody annotate the constructor? So can you show me the code? I don't have the code in front of me.
Oh, darn. What is this, multi-classes?
Yeah.
Yeah. Yeah.
Okay. PyCon, right? Yes. Location. Okay. Did everybody get location as string? Here as int. Did you annotate the talk, self.talks? Yeah. Wait. It's a list of talk. Oh. Oh. Can you look into that? It should have been a list of talk. Did you get that? Is that what you got? So self.talks is annotated as a list of talks. So, yeah.
Doing it like in a different, and I'm on the next one. So like,
Okay, cool.
I don't even remember what.
No worries. Yeah. So yeah, you can follow along here if you missed it. So self.talks is an empty list. So we need to help it out by saying this is a list of talks. So we annotate add talk. So add talk expects a talk. Calendar returns a string. And so you also need to annotate functions because we want Pyre to analyze them, right? So we say get starter takes a talk and returns an int. Did we get that? So did you catch the error? So we're using talk.starter, but talk doesn't have starter, it just has R. So this is the kind of sort of subtle bug you might miss if you're just reading code by yourself, but then if you have a type check, it just catches all these errors across your code base. Any questions about this? Yeah? Okay, that's a good question. So because the parameter was annotated, so location, and the other one was like annotated up in the parameters, you don't need to sort of say self.location : string because Pyre can figure that out. But for things where you're initializing on the spot and not using a pre-existing variable, you usually want to help Pyre out by saying this is a list of talks and things like that. Okay, so yeah, it doesn't hurt though. You can always add an extra annotation. It doesn't hurt, but you don't need to do it. Any other questions? All right, we'll move to the dictionaries and tuples. This is again a bit complicated, so it's okay to get stuck. Like if it takes some time, it's fine. Go to the next URL under dictionaries and tuples.
I noticed for this one, like the ID didn't pick up the type error on this one. Is there like JetBrains integrations for Pyre?
Oh, are you doing it in ID?
Yeah.
Yes. So VS Code comes with support. So I don't know if you have instructions in this tutorial, but yeah.
There's issues with it?
Yeah. So I would just run. Yeah. Pyre comes with VS Code. That's one option. Or you can just run Pyre in the terminal. That would
Yeah.
just, yeah. So yeah, we are sort of improving our IDE support so that you can see stuff. You can do stuff like code navigation
Will
and all
there
that.
eventually be any JetBrains IDE support?
I'm guessing, yeah.
Yes.
But yeah, so right now it's like
We
I
have,
think only Pyre is the major one.
we'd have like LSP support, so anything that reads in like language server protocol should be able to use it.
I'm not familiar with LSP.
Oh, okay. I think a lot of like editors communicate like file changes and expect responses, so like syntax highlighting and stuff, or like error highlighting.
So it's like a common API
Reusable.
for all
Yeah, it's a common
editors.
API for everything, and Pyre supports that. But specifically the VS Code extension right now, I think has some issues. So that's why we're not trying to demo it
Today.
But yeah, so in the future, I think Pyre should be able to support like
But yeah, I think he wants JetBrains in particular.
JetBrains. I don't know how that. I don't know how that communicates with.
How about
Okay, I'm not familiar with.
okay? So if JetBrains is what you use, we can sort of figure that out. But then yeah, if you really want to use type checking, I think right now Pyre is an option. I think in a few months we'll have support for Pyre as well. But then yeah, these are the options right
I
now.
mean, you know, you can just run it manually
Yeah.
every time you do anything, but ideally, yeah, with
Yeah, I mean, that is ideally what we want to as well.
Yeah.
We are working on that.
Yeah, we usually like when you hit save, it'll just populate your errors. So I think right now Pyre is yeah, but we also have to support like for not externally at the moment, but yeah, like and then everything just checks when you.
Oh, so Pyre is like another type of
Yep.
Yep.
Same rules. Yeah.
Yeah, we can probably answer all these in the final email to the attendees. Like we can just follow up questions. We can answer them in the later email. Okay, yeah. Is everyone done, or I know this was a bit more involved than the previous one, so it's okay. Shall we go ahead with the solution? Okay. What did you get for the constructor? Int, and returns none. And then what did you annotate seating? Dict from? Okay, so dictionary from where the keys are ints, and then the values are list of strings. Perfect, yeah. And then where was the bug? You didn't get it? Okay, yeah. Or did you at least get a Pyre error at the bottom when you annotated the functions? Yeah. Okay, so let me show you. So yeah, as you said, you use a dictionary from integers to lists of integers. So I hope that part is clear. I can walk through that if anybody still is not convinced. Yeah. What about? So did everybody get the type of the attendees? The attendees parameter. So we can see that it's a list, right? Because we are looping over it. Let's say we know it's a list, and then we are sort of each item is a tuple of 3 elements. Can everybody see that? Right? Because we say for row, column, attendee, right? So it's a tuple of 3. So what would be the type? It's a list of tuple of 3 things. So and what are those 3 things? So we have row, which we know is an integer, column is an integer, and then attendee is here string. So it's a list of tuple of int string, right? So I hope everybody got that. And then so Pyre would have pointed you to saying that this attendee is wrong over here. So I'll sort of walk through the error. So if you run Pyre, it says that It's a bit hard to understand. It says list.setItem cannot be something that is can't be a string. It has to be something that is indexed. So what does that mean? So I'll walk through that. So we know that self.seeding is a dictionary from int to list. So then we know that row -1 is an integer. So if you look up an integer in that dictionary, you get a list of strings. So this whole thing is a list of strings. And we know that attendee is a string. But you can't index a list by a string, right? We saw that earlier. You can't do foo of some string because that'll be an error at runtime. So that's what Pyre is complaining about. So in reality, what do you think this should be? Anybody has any idea? Column -1 or something like that. So in reality, we intended this to be column -1. So again, there's a dictionary. You look up row, you get list of string, and you look up the column, you get the string that you want. Make sense? So, okay. Dictionary. Okay, which one? The first one? Okay, so it's the outer thing is a dictionary comprehension where you have the key is a row, so row is an int. So we know that all the keys are ints. So it's a dictionary from ints to something. And then now we have to look at the values. So we know that it's a list. And then each element is going to be a string, is it? Each element is a list again. And then each element of that list is a string. So we get it's a list of strings. Does that make sense? So dictionary from integer to list of strings. Yeah. Any other questions? No? Okay, everybody's good. Do you have time? You have time for one quick refactoring exercise? No? Okay, we are over time. All right, we have a couple of take-home exercises at in the README there, so feel free to try them out. And if you have any questions, we're always available. You can ask us. Oops, am I going up or down? So we've learned how to add types to basic constructs like functions, classes, lists, variables. So with this, you should be able to type check the majority of your code. So the rest, we'll see the rest of the tutorial. I'll pass it on to Shannon. Thank you.
Yay. Oh, I should turn this one off. Okay. All right. Oh, okay, awesome, this works. So I need my hands typed. Different mic here. And this next section will be pretty short. We're just going to be sort of setting, actually, let me also do this, setting up an example project so we can try out type checking outside of just the web UI sandbox. And then after this, we will adjourn for a break. So this part's kind of like installation heavy, and there's a little bit of demo on your local machine. So if you have any trouble at any point, just like use the red sticky. People will come around and help. And then also in the break, which is 30 minutes long, feel free to stay after. Like we can help with anything. So just a heads up. All right. Where's my mouse? OK. I'm having trouble clicking. OK, I'll use arrow keys. OK, cool. So first, let's acquire the example project. We've set up a GitHub repository for you that you can fork or clone if you prefer. If someone can come around and pass out these pieces of paper, we also have the setup instructions on paper in case you need to refer back to them or you want to take it home and try it on your own project later. For now, let's all just use this example GitHub repository. So again, if you run into trouble, please use the red sticky and flag us down. And put up the green one once you get this working so I know that I can move on. Also, if you had cloned this ahead of time, just do a quick pull, git pull to update just in case there are any changes that you missed, and that is up to date. There's nothing on the handout that isn't up here, so that's just for reference, so you don't have to read it all. That's fine.
Someone said you changed something today, but nothing got pulled in.
Can you, let's see, if it's already, can you do git log? This is from yesterday. I wonder if the upstream is set correctly. So do you, did you fork it or did you just directly clone it?
I cloned it.
Clone it directly? Hey, Steven, could you help with a git pull? I think you have to maybe set your upstream to point to the right, because the git pull's not getting anything. Thanks. Reminder to use the green sticky if you're done. Yeah.
Sorry, I stepped out, but
No worries.
what's the purpose SSH access? Because we're going to fork it and then maintain our own.
So this is just for the tutorial. So we're just going to mess around with like a local project. So just clone it. The troubleshooting is, I don't know, common issues with cloning. So, yeah. Let me know if you run into it.
If we've already got Pyre running locally, is that what this is?
So I would also recommend cloning this project just because we're going to be using it for examples. So rather than, if you're working on your own project, yeah.
Yeah, got it.
And Arkman, in case you cloned it like a few days ago, make sure you get the most up-to-date.
If you just pull again, yeah. Okay, I'm gonna flash the next screen. No rush. I think most people won't need the next screen. But if you haven't installed Python already or need to install Watchman, which is a file monitoring tool, that's also a good time to install these tools. Python is pretty self-explanatory, but for context, Watchman is a file monitoring service. It basically updates when your files change locally, and Pyre is kind of built for really, really big code bases, like millions of lines of code. We want to be able to give you type checking results within seconds based on your local changes. So that's why Watchman comes in handy. For a tiny project like this one, you won't see much of a performance difference. So if you don't have Watchman and don't want it, you'll be fine. But if you want the full experience of like fast type checking, then also install Watchman.
This is a question out of left field.
Yeah.
Terrible question, but I'm using PyCharm, WSL, and I'll get a message like, "Oh, file watcher has failed repeatedly, ceasing indexing or something of your files." Do you have any thoughts on
File watching has failed?
a file watcher? Is what, like Watchman?
It depends. I mean, Watchman is one file watcher, so I'm not sure what the editor is using in that case. Yeah, I'm not. I don't know. I think I would probably just go with the docs of what's going on there. Which type? Is this Pyrite? PyCharm, right? PyCharm. They probably have. I don't know. I would recommend Googling around their forums. I think they have really decent.
It's a little bit
But-
irritating that if I
Yeah.
kill the app and then restart it, then usually it's kind of okay, and it only becomes a problem with
Like big changes or something like
moderately
that.
large code bases or big changes as well.
Okay.
It'll just give up.
So Watchman is really stable in our experience, but I doubt that that's what they're using. So like we'll do like big like rebases in like million line code bases, and Watchman pretty much keeps up. But I don't know in that case. Like for troubleshooting Watchman, usually we just like ping it and see if it's running. Maybe you can do that under the hood too from the whatever watching service that editor is using. But yeah, I guess this is pretty common across any of the type checkers that are trying to do the like fast updates. Okay, I see green stickies. If you're not able to get this working, put up a red one. Someone will come around to help, but I'm just going to keep moving. Oh, okay. Okay, cool. So hopefully everyone now has a project and Python and maybe Watchman. So now let's actually install the type checker. It's available on PyPI as a package. So these instructions just show you how to set it up within a virtual environment, just in case you prefer that. And yeah, the package works on Linux and Mac really well. Windows support is still on the roadmap, so if you do have a Windows machine, we have a replit, and we also have a Windows subsystem for Linux instructions. And those are all in the email that was sent out earlier, and also on the worksheet, there's a link to those detailed instructions if you need them. But again, use the red sticky here for sure if you need help. Yeah, I think that's it. Give it a try. Running into issues?
Yeah, I can't spell.
Oh, that'll do it.
Now I was just trying to figure out if I didn't install Watchman.
Oh, I'll tell you. You just run a slightly different command, but everything will be the same. Yeah. Oh, don't follow a lot. We'll actually do everything on the slides, so don't worry too much about the take-home next steps. If you haven't seen it up here, don't worry about it. Yeah, this is like for you to take home if you want to try this again on your own project, or if you need to refer back to something that we've already covered and I already moved on. No, I haven't done that yet. Yeah. Yeah. Well, actually, okay, I guess we can hopefully move on. Anyone? Again, if you need help, red sticky. Okay, we can get to the fun part now. We've installed everything, hopefully. Okay, cool. Let's run the type checker on your machine for the first time. So you have a project, you have a type checker. And if you did have problems installing anything, there is a sandbox version of the upcoming exercise. It's kind of limited. Would recommend you do the local setup if you have it, but that's there in case. Okay, great. So now let me also drag. Oh, are we in full screen mode? What's going on? Oh, okay. The orientation's not what I expected. Okay. Okay, cool. So that's just there for reference, so you can kind of see what I'm doing. All right, so let's CD into the project that you just pulled, and then you can quickly take a look around. So we have a few directories in here, but for now, let's start with demo project. So please CD into demo project. And if we look around in here, we just have basically two little Python files. There's a greet.py, planets.py. If you're curious, this is just a little program that asks you how many times to say hello, and then prints hello world that many times. Pretty simple. So let's try to run this through a type checker. The first step to do that, let me also make sure that I'm, can I make it bigger? Probably. I don't know if that's actually helpful. Okay. Oh. Okay. So everyone should run Pyre Init. This is a really easy way to set up a Pyre configuration. And you can just hit enter, accept all the defaults. Just for context, you can run Pyre by passing in what you want type checked manually on the command line. But a configuration is just an easy way to avoid typing that every time. It lets Pyre create that server that does the fast type checking with Watchman that we talked about before. And it makes sure that your project is sort of consistently defined as a set of files for future type checking. So always recommend just running Pyre Init. And then let me CD into that project down here too. Okay, so now if everyone has run Pyre Init and just hit enter a couple times, let's just try running Pyre. And you should see a type error. I will just type Pyre. Yep. And again, red sticky or raise your hand if you need help. Yes, we're expecting to see an error. So if you see a type error, you've done it right. Hey, what's up?
I didn't get the error I got.
Invalid configuration. Oh, do you already have a configuration set up? Can you do ls-la? Oh, oh, yeah, that's fine. Can you open up your local configuration?
Where was it?
Oh, it's just, sorry, the .pyre configuration local, if you just cat that or vim it. Yeah, yeah. Oh.
It asked me for like the deck.
Oh. I would just put a dot in the string there just to say I want to type. And maybe that was like a weird input into that prompt. Just in the quoted string.
Well, in demo, right?
Yeah. Yeah, and now try it again. Configuration option. Oh, do you have something higher up? Did you run Pyre Init maybe in the pair? Oh, so go back up and just delete that. Yeah, that's why. Yeah. Anyone else need help? Oh, hey.
I'm just getting saying that Pyre's giving a non-zero.
No Watchman binary. Okay, so you don't have Watchman?
Yeah.
Oh, just run Pyre check instead. I thought that maybe it would just handle that.
Space check?
Yeah, space check, yeah.
I created this folder, and then I cloned into that folder.
Oh, what happened here?
So I'm on like a engineering computing build for my company. So I'm on like Suzy 11 or Suzy 12.
Did you successfully install Pyre from pip? Like, did that work?
Yeah, the pip, installed from pip just fine. The init stuff was kind of weird, where it was asking me about. Well, it's going to give me the error saying I've already got it.
Oh, that's okay. No.
So just enter through all this.
Oh. Let me get. I should move on, but hey, because maybe help here. There's like a weird. Pyre's not like exiting with a weird error.
Tell them about the break coming up soon. People are hungry.
Oh yes, break is almost here. In case anyone's hungry. Hi, nice to see
I
you.
wanted to remind you that the break was at 3. I forgot to do that earlier, so that's like 4
Oh
minutes.
yeah, we're on track. Yeah. If you're really struggling and you don't, I'm going to move on just so we're on time for food. You can use the sandbox link if you want to follow along with the rest of this example, but don't have it working locally. And then the break is 30 minutes long, so we can also help with more gnarly stuff if you're running into installation problems. Okay, let's move on. Again, feel free to use that sandbox link here if you need to. But hopefully most of you see a type error. So now let's do something about that type error. Let's investigate. So it says it's in greet.py, right? So let's all open up greet.py. Okay, and if we look at this function, it looks like we ask the user how many times you want to say hello, and then you print that many times. Based on the output here, does anyone spot the problem or know what we would change to fix it? Yeah. Yeah, so you need to make sure we're passing an int into greet. So that's definitely a type error. Pyre is complaining about it. And if you are curious, if I can find my mouse, you can also try this out at the runtime, right? So if you do Python 3 greet.py, you ask okay, how many times do I want to greet? Let's say 3 times. And bam, this crashes because you can't pass a string, which I just passed in, to this function that's trying to iterate over a number of times to print. So let's fix this. So everyone should just follow along here. Maybe like the easiest fix is to cast the input to an integer. Lost my cursor. Okay. Okay, cool. So we should fix that. And then you can go back here and run Pyre again. And now it should tell you no type errors are found. If you don't have Watchman set up, you can run Pyre space check. That will basically not try to look for file updates. It will just recheck your whole project. You might notice that this run was like a tiny bit faster than the previous one. It doesn't make a big difference in a small project like this. But in a really large project, even if we had like millions of other files here and we just ran Pyre like this speed would be consistent. So it doesn't, if you're running incremental with Watchman, you aren't like blocked on rechecking all these other unrelated files just because you wanted to update based on what you just changed. All right, I'm going to keep moving. Again, we'll be around to help if you need to. If you need to help get help after. So yeah, we should see no type errors found after we made those changes to greet.py to cast to an int. So now let's say that we realize that actually it's kind of silly to greet the same thing multiple times, and this is actually not useful. And we want to refactor our greet function here to no longer take repeat count. So let's all change that. We can delete this input. Right, we're just going to just print the greeting straight up. We don't need this anymore. And we can also, of course, don't forget to refactor the call site to no longer pass in the parameter we don't support. So let's write that. And then we can run Pyre again, just to see. Like, oh boy, OK. So we actually got, sorry, we actually got a type error. Maybe we weren't expecting this because we were just heads down in greet.py changing things around. But it does turn out that our project has another call site somewhere downstream. Like maybe we don't own this code. Maybe it's just something that depends on our the function that we just changed. And it does turn out that if we look at greet.py, not greet.py, vim planets. So here we do see that we have another function that depends on greet, and it is passing in a parameter, and we just didn't know about this call site. So when we made the refactor, Pyre is checking all the call sites for us to inform us that this is a problem. So you can feel free to fix this locally if you want to. We also have, I think my window is maybe gone. That's OK. Just in the interest of time, I will skip that part. But if you do make a pull request here and upload that pull request to GitHub, you can set up Pyre to run on all pull requests in your project. So if someone were to say, make this refactoring change, not fix the planets.py call site, because maybe they weren't running type checking locally, and they made a pull request, you can have a check that will run Pyre on every PR and inform you that this isn't safe to merge until they fix it. During the break, I can pull it up if anyone's curious. But yeah, I think that's it. So we've covered the sort of basic motions of how you interact with the type checker on the command line. Pyre can also integrate with code editors to show errors in line as you type. But for now, we will just adjourn for a break. You can kind of continue to mess with the example project if you want to. We'll use it again right after the break. And of course, feel free to stay if you have any questions or you just want to talk to us, not about this specific installation process. We're also happy to talk about other things. And yeah, I think the break is 30 minutes long, so we will start at 2:30 sharp back here with the next section. Oh, sorry, 3:30. I'm on the wrong time zone. Yeah, enjoy the break. All right.
I'm going to have
is a struggle. Yeah, so this will run a full check, and then it will print out an error on there. And you set this up with a like YAML file, basically whichever like project you want to define. You can just check in. It's in the.
The YAML file configures Pyre.
Well, so we have a Pyre configuration file like we created that just says like, oh, this is the directory to type check, and the YAML file just calls into the Pyre action, like GitHub action, and that's on the GitHub marketplace, so you could download that. But yeah, so you can sort of see like, okay, something went wrong.
We don't use GitHub, so.
And then.
This is like this in the Python typing tutorial. There's a sample GitHub action configuration with the job.
Yeah.
Run the Pyre action, right?
Yeah.
That's at a follow up.
Yeah.
This one's a little more high level though.
Sure.
It's just kind of, so I love type checking. I love like linting and stuff. Something I have trouble as like as a more senior developer is trying to get the juniors to actually like do it.
Oh yeah. Okay.
'Cause in a lot of ways,
Yep.
like I can type annotate the whole thing,
Yeah, I mean, it's
but,
not
like,
practical
only one
to-
person.
yeah.
Like, I can't. And I guess like, did you have any thoughts or any ideas how to like kind of, because I really believe in the like, oh, just like, you know, beat them with a stick and tell them to do it, you know, because that's
Yeah.
not how people work.
No,
You
it
have to make
isn't, yeah.
like, enjoyable. So do you have any like tips on maybe how to get people to actually like use this?
Yeah, that's a great question. It's actually kind of the focus of the next section too. But yeah, so we basically, I guess for context, and I'll mention this to everyone, we basically type checked all of Instagram's server code base, which is many millions of lines, and it went from like pretty much lacking types to I think 99% covered over the last few years. And so we built a lot of sort of auxiliary integration tooling on top of the type checker to like maybe make it really visible, like whenever anyone's typing anything, like, oh, are you missing types? Like, what's the type coverage of this file? Like on CI too, you can sort of show like type coverage and the effect of your current change on type coverage. So it's sort of like making it really visible to anyone who's changing or writing new code, because it's always easier to add types like when you have that context rather than someone like sweeping the trash after, like trying to keep up. And
the score metric that it's like
yeah. So we would track like contributions of individuals too for like better engineering pushes, or just like kind of over the long term, like are you generally contributing to typing efforts, like wherever it's convenient for you. We have like automated tooling and a lot of other things too to add stuff. Sorry, I'm talking a lot, but I'll go into all of those. Yeah.
I'm just curious because I'm in a totally different context. Like I'm at like a startup with like 9 people at this point.
Oh, okay, yeah.
So like I'm trying to find like, okay, what tooling can I like pick up that will kind of give me my best like bang for my buck? Because like rather than being like, hey guys, we need like a whole,
yes,
because right now we're even like, we're trying to get our CI/CD going, but is that kind of like we need to like make sure it's like, well, what are we getting?
Yeah.
Kind of thing, like what's the benefit?
Yeah, that makes sense. I think practically speaking, for like I want this today, I think there are a lot of other type checkers with like better open source support right now than Pyre. Pyre has a lot of like really awesome tools, but a lot of them we haven't ported to open source, so we want to do it soon. So like some of the things I'll mention, like gutters, where you show the coverage and that's just integrated into your editor. Like we use that internally and we want to make it open source soon. It's just like, we need the hours to do it. So in that sense, like some of the things I talk about, like the tooling itself might not be immediately ready for Pyre, but I do think that like Pyrite has really good editor integration, at least for showing types. I don't know about like actually showing coverage or things like that.
Cutting edge thing, like it's a more
Yeah.
Like the direction where things are, because I know the type annotations are relatively new too.
Relatively, yeah. I mean, they used to just be comment strings, and type checkers would parse the comment strings. And so now they're in the syntax, and I think it's growing really fast, which is kind of exciting. But yeah, like trying to, like tooling for coverage. I'll show you some like automatic type inference engines too, to just like kind of do a lot of the trivial work at scale, and that's available right now. Some other stuff too, like we'll talk about like type checking modes, and if you want to like enforce that all new code has types, like what you can do that, things like that.
I think if anything, I might just steal the like percentage, because I don't know, like.
What do you mean?
Oh, like just having like a metric.
Oh yeah, no, it really makes a big difference.
Like even I don't know if it's not even like an enforced metric, it's just like, hey, don't you want this number?
Yeah. Because like we've made like dashboards internally and stuff, and I think that it's really helpful. People just like be able to know at a glance like what the state is. That's pretty motivating. Yeah, of course. Hey, what's up?
I saw a couple of your talks online. I'm like,
Oh, really? Oh gosh, I always hate watching myself speak after the fact, but I hope they're okay.
I'm like, oh my gosh, I need to.
Oh, thanks.
How long have you been in Meta?
5 years. Yeah.
Do you mind to share experience? Like, how did I get there? Because I'm just transitioning. I just created my own project.
Oh, cool. Yeah. Just like how.
How to get there? Because I don't have any woman probably advising me. Like, you have to do that. You have to do that. Like, I have
Yeah. I think maybe a lot of it boils down to like interview advice. Even I actually think a lot of tech companies, I think Meta included, aren't super like strict about formal like, oh, you have to have done like XYZ like previous things. I think so. Yeah. So you'll do the interview process. I mean, it really depends on like I guess like what level you're interviewing to join at, because that like I think they'll ask more like system design questions or like previous experience at working at a software company questions for like the non-entry level positions in the interview process. But I mean, I joined straight out of college, and so I had no. I didn't do an internship even. Like I just interviewed, so I had no like previous job experience. So I interviewed, for entry level position, and they really just. It's an entry level position. Yeah. And they just like they will just ask you like coding questions, so you can kind of just like demonstrate. Like they just want to see your thought process, like while you're coding and things like that. And so I guess that's the only context I have. I don't know if it's actually useful advice, but yeah. Oh, okay.
Just try something new.
Yeah. So they also have a rotational engineering program for people who are switching in from like non-traditional background. So maybe you should look at that program. It's called the rotational. I don't have like off the top of my head. I don't know, but I think if you Google like Meta rotational engineer, you can probably find something about it online. And I also know that Meta has a booth at PyCon. I think we sponsor PyCon, and so in some of like the, when there are tables, you should go ask someone there too about like how to apply to the rotational program. Yeah, that's right. Yeah, so actually someone on our team from a couple years ago joined the company through that because she had like switched from a different profession as well. So that might actually be a good, yeah. So boot camp is not a track. It's every new hire goes through boot camp. It's just like a way to introduce to the company. No, it's not really like it's not a test, and it's not boot camp is maybe a harsh word for it. It's really just like, oh, here's like get to know like our internal tools. You can pick a team. Like it's like that kind of stuff. It's like onboarding. It's like basically onboarding. So boot camp is not actually a boot camp. It's like the what we call the onboarding process. So everyone does boot camp. It doesn't matter like what job you have. If you join the company, you do boot camp. But this is actually a track of, I think, a hiring track where. As far as I know, and I'm probably not the person who knows the most about it, you kind of sit with, I think you may like work on an engineering team and you get to try 2, I think, like for 6 months at a time before you commit to like joining a team full time. So that way you get like a little bit more diversity of experience on like different teams. And then, yeah, so you should, Oh, cool, yeah. You should definitely talk to. So like I'm just telling you like what I remember. So I might not know everything, but you should definitely find the Meta booth and ask them about it there. So I think so. Yeah. I also don't know the schedule very well, but like whenever the tables are, like I know there are a lot of people tabling. Yeah. You can ask them about the rotational program. At least if they don't know, they'll probably get you to another person who does. So I'm just passing down the chain. But like, yeah, at least, and the website should probably say something too, I think. But yeah.
Do you have an opinion for me, like a beginner, if I would do like that certification of cloud stuff? Meta has it, right?
Ooh, I don't know. Yeah, so security and programming languages. So no, I don't know about that. Yeah, I have no idea. I don't want to say the wrong thing. So yeah, yeah. Yeah. Okay, I hope that, yeah, I hope that's helpful, but yeah. Oh, no, degrees are not necessary. I don't think. Yeah, no, I don't think they even ask like I remember when we were applying out of college, like they don't even ask for your transcripts. Like I think it's really a lot of it's based on the interview. Yeah. I would really recommend preparing. I think it's not something you want to go in blind, because I think you can get a lot out of like just being familiar with the types of questions, like reasoning about like data structures, because they're all. Yeah, we're good. It starts again at 2:30. Yeah. I will have to speed a little bit of my second section. I'll make sure to leave you 65 minutes. But yeah. What? Yeah. Actually, you might want to even set up another one. But yeah, you can, or we can just transfer. Actually, it's fine. No, it's okay. Well, I'll just give it to you when I'm done. Sorry. What were we talking? Interviews. Cracking the Coding Interview is a really great book. Cracking the Coding Interview. Yeah. I remember when I was studying for it. I found it really helpful to like do a lot of read through it, do a lot of the exercises, but then save a lot of them to just simulate interviews where like you're asked the question, and then at the time we were doing in-person interviews where you would whiteboard the solution. So yeah. So I really I remember I would book a room with like a big whiteboard, and I would just do the problems on the whiteboard to practice. So that helped me a lot. I think actually after you do a lot of them, you start to like get a feel for what kind of problem is this? Kind of like on site, you can kind of like bucket like, oh, this is like this kind of a question. It typically uses like mappings, or like it typically uses like a tree search, or typically. So I found that super helpful for preparing for interviews, just like doing a lot of those questions. And you can find some online too, like just typical coding interview questions, like Googling for them. A lot of those are, yeah. Yeah, well, I did some on the computer. So usually the interview process is like the first round is online, so it's on an editor, shared editor. And then like final rounds, they used to do, at least when I interviewed, they did it in person on a whiteboard. These days, I think they're all online still because of the pandemic, but I might transfer back, I don't know. So I practiced some on the editor and some on a whiteboard, and I thought that was helpful. Yeah. Yeah, it's I don't know. Interviewing is like a whole thing to worry about. I feel like sometimes it's not exactly what it's like. It's not exactly the same skill set, I think, as like developing a project in a large code base, but you know, it's just something you kind of have to hammer at. Yeah. Oh. I think it probably really depends on like where you're starting from, because I'd done a lot of prep before for like internships and stuff like at other companies. So I don't know, I don't think an estimate would be very helpful, but there are hundreds of problems in that book, and I spent like a good couple weeks, just doing problems. But that was kind of from the point of having already read the book and like kind of familiar. I don't know. Yeah. I mean, that's just, again, it's just my own perspective, so I don't, I know. Yeah. No, I think that book really helped, and just like hammering out a lot of the questions really helped me prepare for it. I think I did most of the book. It's a lot. It's a lot, but I think it's really helpful. Like once you start feeling like, oh, I see a question and like already know where to start, I think that's really helpful, because sometimes what hits you is like someone asks you a question in the interview and you just like don't have a starting point, and that can be really stressful and like kind of throw you off. But at least if you know like, oh, like this is what I can start talking about or start thinking about, it's like a lot easier to just like, I don't know, like not get surprised. What?
Kind of like pattern recognition.
A little bit, yeah. At least to like, what framework should I use to start thinking about this problem? I think that kind of helps. Yeah, but again, that's just how I happen to study for it. But yeah, and if you have questions too, like Alex and Simran are both Facebook engineers, and they've both done, or at least I think you guys both interned, right?
Yes,
Did you intern? Oh, okay. She went through the interview process more recently. If you have questions, but yeah, I don't know if my knowledge is outdated. Yeah.
that is definitely hiring, sir.
Yeah.
So I looked up this full screen Google Sheets thing, and there's like a million people trying to do the same thing, and it's very hard to do. I think the only way to do it is
It's my first time too. I'm not in a Python.
Is there water outside?
Yeah, just go out and take a right, and then another right.
This guy I'm talking about, I think he's like really, really
Do you mind if I leave this in the corner? Okay, thank you.
Yeah, I did some research on this whole full screen thing, and you're not
Oh,
alone in the battle.
really? Okay, people struggle with it? I'm so surprised that they don't do this.
I'll show you like what the best solution is,
Oh, okay.
but it definitely seems like one, you should probably start with like no other Chrome windows, no other desktops. Like you need to almost like start from the beginning and execute this. And then most people just say it doesn't work. The best voted solution in
Yeah.
every forum
Yeah.
is exported as a PowerPoint and presented.
We honestly we were gonna do that.
Second best.
Oh my
solution
gosh.
Suggested.
Press the S button. Oh.
So like go full screen, then pop up the presenter notes, then drag it over, then make it full screen again.
Okay, I'm not gonna try this right now, but thank you for doing the research.
Yeah.
That's good to know.
So
Yikes. I'm shocked that Google hasn't figured this out. Okay. I'm
or just like Google refuses to write software, right? Everything they do is browser based.
yeah, that's true.
What you really need to do is have an actual piece of software
That you can install. Yeah. That makes sense. That's a. That just runs what? Oh, really?
I just need enough information to it.
All right. I mean, your screen looks like it's got kind of crazy stuff going on it too. It seems like.
I'm in south and I always forget to take my laptop and it froze.
Oh, yeah. I mean, it sounds like that's a good reason to get a new laptop as well. But it's. Yeah. Yeah.
And that's what it is, those hinges get really cold.
Oh. Wow.
Yeah, I looked in the back hall. I was going to see if there was actually the other one. Because I've got this cable here. And I was going to see if I could do it.
Good. He actually did a bunch of research into the full screen thing. the forums are all full of angry people who can't get it to work. Yeah, so he was just like the top voted comment in everything is converted to a PowerPoint. So I guess next time we know. Yeah, that's I know you have it working nicely. Apparently it's horrible. Forward looking. So hopefully this will answer them, but it's kind of nice about it.
I'm happy that somebody asked.
Yeah, and some actually, okay, well, like, I'm a senior developer in my company. I find it hard to convince junior developers to do this. Like, I could beat them with a stick about it, but like, how do I, like, what approach have you taken to like get a code base like realistically converted? And I was like, wow, I'm glad you asked. That's great. Yeah.
There's a racing car company, and they work
Whoa.
there, and they're trying to add Python. And
Oh.
people there are opposed to it, so they're like trying to convince. So he brought two people with him from the data pipelines, and he's like training them. So
Oh, that's cool. All right. Can I get the mics? Thank you. Oh, sorry, what?
Maybe just like make it clear, eyes under something.
Oh, yeah, like whether, yeah.
So everybody's paying attention.
Okay. Yeah, okay. Hi, everyone. All right, we're going to get started again. It is 2:30, and we got more stuff to cover, so I want to make sure we get to it. What's on the screen right now, if anyone was out, is just like what the GitHub CI looks like when you submit a PR with breaking changes. So that's just for context, but I will move it off the screen now. Oh gosh, where'd it go? Okay. Okay, great. Okay, so where were we? All right, so just as a reminder, things that we already went over in the first half included what are types, why we might bother using them, and then how to type some basic Python data structures, and also how to run a type checker on your local project, the playground. And so in the second half, things like the first one are that you might take when you're pre-existing projects that are huge, not just like toy examples that we've been looking at already. And then in the second part, we will be talking about interesting features in the type system and how you can express more dynamic patterns in the type system. So that's what's on the agenda. Next. Okay, so as you might guess, and I think some of you have mentioned this already, adding types to a real existing project poses some challenges that you won't run into or we haven't run into already. So let's kind of identify them and talk about how we might approach them. And a lot of this is based on our experience annotating the entirety of Instagram's Python server code base, which is definitely a real-world project, millions of lines of constantly changing production code. So that's kind of the experience that we're speaking from. First thing that you might run into is that you may find yourself adding type annotations to a huge existing code base. And thousands or millions of lines of untyped code mean that when you run type checking over it for the first time, you're just hit with a wall of type errors. And you might not have a week or 2 weeks to put aside to just dedicate to fixing those errors. Like you have other things going on, you can't just halt all other work. And on top of that, you might feel like adding annotations one at a time is really just a drop in the bucket, and you're never going to get anywhere with real runtime guarantees, just going one manual annotation at a time. So that's one issue. Secondly, many projects have multiple developers, and they have code bases are constantly changing, code is being added, et cetera. And so we care about maintaining a consistent developer experience for everyone touching this code base. And we also want to make sure that any hard-earned coverage that we do add doesn't just slowly erode over time as that file gets changed and updated. So finally, realistically, most projects have some legacy code that might contain really highly dynamic patterns. And you may not have time or the desire to refactor it up front, but you might still want non-noisy type checking on the rest of your project where it can provide value. So we'll talk about how we can get around this. So, given all of these things, like you might be feeling like it's really daunting to be adding types to a pre-existing code base, and it's not like, we all aren't busy enough already. So, so what can we do about this? Thankfully, there are some tools that make this task more incrementally approachable and doable and practical even in a massive code base like Instagram's with constantly changing production code. So we'll talk about approaches that let us gradually but efficiently convert a large untyped code base into a typed one, how to circumvent some of the extra tricky bits of the code base while still providing some useful stand-in types or escape hatches to just shut up the type checker when we need to. And then we'll also talk about how we expose consistent expectations for type checking and defend your progress. So starting with the first thing on the list, which is gradual typing, we're pretty lucky that the Python type system was defined with a built-in solution for onboarding large, poorly typed code bases. Namely, as we've run into a little bit already, type annotations in Python are always optional. And there are a few ways in which this is true. So first of all, type checkers will not analyze the body of any function whose signature doesn't contain at least one type. And this way, you can add annotations at your own pace and resolve errors that are kind of local to the context that you have and whatever you just added annotations to. And under the hood, the type system comes with an any type, and all omitted type annotations are implicitly treated as having the any type. So this type is compatible with every other type in your type system. So you can always take any, you can always pass any, and there will never be a type error that involves any. And if types are omitted, the type checker assumes that the omitted type is an any, and this effectively stops any type errors from propagating further against that value. So a function that has no types is assumed to take any, is assumed to return any, and the body of that function is omitted from type checking. And this is true of all type checkers. This is kind of defined in the Python type system. And this behavior sort of creates a waterfall effect where you'll very likely see few errors, if any, when you just start adding types to your first module. Any errors you see will probably be against the standard library or against literals in your code. But gradually, every annotation that you add to your project will have more to check against. And so as any's are replaced with meaningful types, type information can start flowing through your code base. And we usually recommend, therefore, starting with a very centrally connected dependency or like a commonly used module when you start adding types to just see the most benefits early on in the process of onboarding a large untyped code base. So all of these features together describe what we call a gradual type system. This means you can type check your project even if not everything has types, and the type system supports features that let you add annotations incrementally and deal with the fallout of those type annotations incrementally. Here we see a fun zoomed out picture. It's a dependency graph of Instagram's server code base from many years ago, and it's only grown a lot since then. And so you can kind of see you can start with some interconnected modules, there's many to pick from, and sort of go outwards at your own pace. And hopefully this just helps visualize just how unrealistic it might be to try to add annotations and deal with all of the downstream fallout in one go, and without sort of the hard stops that gradual typing introduces. And in case you want more detail for yourself to read after, PEP 484, PEP is short for Python Enhancement Protocol, but PEP 484 is the PEP that introduced the type system and sort of defined the gradual type system, so you can explore that on your own if you're curious about some of the more of the details. Okay, so now let's kind of poke at some of these gradual typing features in our demo project that we cloned before the break. I don't recommend using the sandbox, but if it's not working, or if something happened with installation, that's still an option. So you can use that short URL. All right, let me pull up my, all right. Okay, so let's quit out of whatever we had open before. We can cd back up into your parent directory and follow along locally. And then let's now enter into another directory, which is called Gradual Typing Project. So I'll cd into that. Cool. Okay, so there's a lot here. But at a glance, we see like, okay, there's a pet.py. Like maybe we have some pets. Maybe they interact with each other. We don't have to worry about that for now. Let's all just first open up main.py. OK, so here we see two functions. Basically, if we focus on run, oh, I am also behind here. OK, so we see two functions. There is run.py. This calls the other function in a loop. More or less, it does some printing, it does some math. That's about it. So let's run Pyre Init again to create our configuration. And you can take all the defaults. And then just run Pyre. So before we run Pyre, what output are we expecting from Pyre? Any guesses? Yeah, no errors. OK, we'll run it. No type errors found. OK, and this makes sense because even if there are type errors within the bodies of these functions, there are no annotations anywhere in this file. And so the type checking is aware that these functions exist, in case they're imported somewhere else. But it's not type checking the body of either of these functions. So let's change that. Maybe starting with run, let's just slap on a really simple one. So this doesn't return anything, so let's just say it returns none. Really, the difference here is now there's a type annotation, so we've opted this function in to type checking. So let's run Pyre again. Interesting. OK, so it's now complaining that on line 19, I'm not allowed to be adding a string to a float. OK, that makes sense. But if you notice on line 18, right above line 19, doesn't it look like we're basically doing the same thing, right? That line is pretty much identical. We're adding a string to a float. Any guesses as to why Pyre caught the one on line 19 but not the one on line 18? Shout louder. Yes, exactly. So in case you didn't hear it, Pyre is looking at getCatDogRatio, this other function, and it's saying, oh, the return type's missing, so it must be any. I'm going to treat it as any. But so that's line 16. But on line 17, we see that we're using the built-in division, and that is typed. It's returning a float. So really, the gradual typing is kind of putting a hard stop on the return annotation of getCatDogRatio, is just treating it as any. So anything that calls this function is going to assume that it's going to get back any. So that's basically suppressing the type error on line 18. So let's also change that. Why don't we annotate this correctly? So this returns a float, right? OK, and now let's run Pyre again. And I will also catch up our slides. OK, I think we're on the right track. So let's run Pyre again. OK, we see both type errors now. Does that make sense to everyone, like what happened there? OK, so let's also say, for the sake of example, that while I was annotating getCatDogRatio and saying it returns a float, I realized that actually, should this always return a float? What if we don't have any dogs, right? This is going to crash. So maybe we should say if dogs is greater than 0, then we return this float. If you run Pyre after this, you will notice that this function body has already been opted into type checking. We will catch this. It's pretty similar to some of the examples we maybe have seen before. All right, great. And again, use your red sticky if you aren't getting to 3 type errors at the end of this exercise. If you do see 3 type errors, go ahead and fix them just for fun. Don't spend too much time on it, but it shouldn't be too bad. I will go ahead and do the same thing here. So maybe first of all, we want an optional, right? Because this sometimes returns none. We fix that. Oh, OK, we have some more errors. Here we maybe, since this is sometimes none, we kind of have to handle that. So maybe we want this to be none, if not else this. And we probably want to cast these to string. Oh gosh, this is so confusing. All right, and if you did a couple casts, did a little non-handling, you should get back to no errors. Again, red sticky if you're stuck, and someone will come help. So hopefully this kind of provided a very scaled down, let me get back to the slides. Very scaled down insight into how the gradual type system works. It basically allows you to incrementally address type errors against things that you're currently annotating without having to tackle the whole project at once. All right. OK, so in the interest of time, I will just leave this as a take-home exercise, like the continuation of this example. Yeah, I want to make sure we get to some other things. But in a gist, like what we were covering here is essentially like if I practically were trying to annotate this project, maybe I would recommend starting with pet.py. That's defines a bunch of pets, and the other files kind of use those pets. So if I add annotations to pet.py, and then I start adding annotations in the rest of my module, gradual typing will mean that I have something to check against, and I'll start seeing meaningful type errors kind of out of the gate. So I won't actually demonstrate this live, but if you have questions about it or you want to try it, even at home, and you want to message us about it after, that's also totally an option. Another thing I kind of mentioned here is if you wanted to basically hand wave a type that you didn't know, like say, I guess I'll just show it, but you don't have to follow along. But if you wanted to say, let's look at park.py. We have a function in here that takes in a JSON input and turns it into, basically looks at all these fields and turns it into an object. So I think there was a question earlier about like how do we handle like gross dictionaries with nested inputs. So like the very, maybe not recommended, but a possible instantaneous workaround is to just say like, oh, input is a list of a dictionary from string to any, and any can really be anything here, and I'm just going to say whatever I take out of this dictionary is fine, just don't worry about it. But there are some other things we'll explore later, like data classes, type dictionaries, or I think Pradeep earlier mentioned recursive type aliases that could let you actually specify every single nested type in this dictionary. Yeah?
Is there some tool where you can point it to a JSON file and say, hey, come up with the specification of this?
We have a tool that essentially looks at what object you're passing in at runtime and then compiles a type out of that. So basically, yes. Yeah, I'll demo it on a future slide. It's called monkey type, and we use that a lot, actually, for a lot of these situations. Yeah, so that's a bit hand-wavy, but let's just keep going. There's some more concepts to cover. So, we've talked a little bit about how you can just incrementally add types to a large code base, but we haven't really addressed like how we scale out this effort so we get to a point where we're actually getting meaningful guarantees, right? If you have sprinkle a few types here and there, like you're not going to get the confidence that any change I make is really going to, catch everything. Some approaches we've taken at Meta and at Instagram to really drive type coverage include having tools that expose coverage visually. So this might be making it clear to authors, like program authors, like what is and isn't covered, where type errors might be missing, especially in code that they're already touching or have context on. And then we can also use coverage tooling to expose progress over time, individual contributions, and kind of track, like make it at a glance clear, like what the current state of the world is in terms of coverage and what effect you're making on it. Another thing we rely on heavily is automatic type inference. So like the tool I just mentioned, which uses runtime types to guess and apply type annotations. We have, the runtime one. We have a static one as well that just based on the control flow tries to guess types and just bulk adds annotations for you. And then finally, we have different type checking modes. So when you're ready to kind of move away from the leniency that gradual typing provides, different like stricter type checking modes can basically provide stronger guarantees in exchange for that leniency. So now let's kind of talk about each of these in some more detail. So first one, coverage visibility. This is kind of a simple idea, but it's actually really useful in practice. We've driven, I think, the Instagram code base from basically untyped to 99% typed. That's millions of lines of code over the past couple years, and this is one big way we did it. We kickstarted some better engineering pushes that really relied on coverage tooling to track progress and identify like hot modules where type coverage was low and we maybe want to prioritize first. So let's kind of look at the raw data that the type checker can provide about coverage. So in your in your project, so we're still in Gradual Typing project, you can run Pyre statistics. I'm covering up the command. Let me move this to the other side. Pyre statistics. And -- print summary is just a human readable version. So we can start with that. And so, it tells us, OK, overall annotation rate, like globally accessible values that could be annotated, 13%, and some other stats. If you're curious about the machine output, you can run Pyre statistics, and just it dumps a huge JSON. But we have a lot of like dashboards and other tooling that consumes this JSON, and we can expose it, in dashboards for like high-level metrics. We can show gutters in the editor to demonstrate where coverage is and isn't missing. We can also show this at pull request or diff time so that authors know what the impact of their current immediate change has on type coverage. So those are some downstream consumers of this data. So.
How long should that take to finish? I believe it may be hanging for me.
Oh, are you running it in Gradual Typing project?
No.
OK. You should cd into print summary. That's for the human readable version. Also, red stickies if you want personal help. But yeah, other questions about this before we move on? OK, cool. So that was that's the first one. Yes, we'll get into that a little. That's a good question. So unsafe is what we call gradually typed modules. So any module that's gradually typed, we count as quote unquote unsafe. We'll talk actually, I mentioned earlier type checking modes, right? So strict is another type checking mode. So that's what it's telling you about there. And yeah, again, we'll cover that right after inference tooling. So not all type coverage has to be added manually. Although human input is usually a really good starting point that a lot of tools, like automatic tools, kind of feed off of and scale out once you have a little bit started. And you still need the human expertise for a lot of tricky cases. But we've leaned really heavily on automatic type inference to just bulk take care of all of the simple cases that the machine can guess. And so we both have Pyre Infer, which is a best effort static analysis tool that right now it's kind of undergoing some changes, but it will guess all of your simple cases. And then we have monkey type, which is the dynamic runtime one that will sort of read in what the objects are at runtime and then create types out of that to add to your project. So let's give both of these a try. I will move this back over here. So for the first one, let's just run Pyre Infer -- in place. And the in place flag just tells the tool, I want you to directly change my files. Otherwise, it'll output them in a separate directory, so it doesn't touch your stuff. OK, so we did that. Let's run Pyre statistics again. -- print summary. Am I missing a Y? OK. OK, so we were at 13% before, and Pyre Infer just slapped a lot of nuns on, honestly, a lot of returns, and like a lot of really simple stuff. But we're at like 48, and in practice too, that is a big proportion of types in any real-world project. A lot of them are pretty simple. A lot of them are none. Maybe you want to do this like a module at a time, and it's a little easier than going through it manually. Let's also try monkey type. So you can feel free to just watch if you don't want to do this, but if you want to follow along, you're welcome to. So pip install monkey type would be the first step. And then you can, let me actually, before I do this, there is a type error that we did not end up fixing because we skipped some things. So I will quickly comment out the problem. OK, so now let's do monkey type run main.py. OK, so this ran the program, printed those stats that we were dealing with earlier with like floats and things. And we can just show monkey type list modules. Tells us what modules monkey type knows about and could add types to if we wanted to. So let's try monkey type apply to each of those. So it's going to add a bunch of stuff. Monkey type apply to another one, and the final one. OK, and now let's do the statistics again. Like, oh, wow, we didn't even do anything. We're at 83% covered. And if you want to, you can kind of git diff. Look around at some of the annotations that have been added. Again, feel free to play with this at home. But you can see like it's guessed a lot of these types. I don't know if this is helpful, but yeah, see I added the any manually, so that's there. But yeah, a lot of these are inferable either at runtime or statically, so we can get a lot of coverage for free, kind of, with a lot of these tooling. Any questions about this? Nope. Okay. Cool. And the last thing that we mentioned earlier is, gradual typing and how this quietly accepts untyped values as any and doesn't check function bodies. So like, what if we spent a bunch of time manually adding annotations, automatically adding annotations, and now we're ready to trade this leniency for stronger type guarantees? So strict mode can be turned on per module or all at once for your whole project if you're ready for that. And it will throw type error on any non-local value that's missing an annotation and would have injected an any into your environment. So as you convert more and more modules to strict mode, the number of any's floating around in your code base will decrease, and you'll hide fewer and fewer errors as a result. Strict mode is also another really useful way to kind of prevent anyone else from adding new untyped code to a module. And you can kind of use it to avoid coverage decay over time. If you've fully annotated a module, you just want it to stay that way indefinitely into the future. You can try this if you want by opening up, say, like pet.py. Pyre strict is the way you opt in just a single module in an otherwise unsafe or gradual project. And if you run Pyre now, you'll kind of see like missing return annotations all over the place. And these need to be fixed because they're introducing any's. So now that we've talked about gradual typing, which provides smoother onboarding, and then strict typing, which provides stronger guarantees, I want to be just a little more specific about exactly what guarantees you can actually expect when we're converting things to strict, and at different stages in the process. So when you just have a module that's strict, you do guarantee that all code in that module is visible to the type checker and being analyzed. And that module itself is not introducing any more any types into your project's environment. However, if you have dependencies that are poorly typed or not strict, those dependencies could be giving you any types, like injecting them into your local logic, and that could still result in missed type errors even in a strict module. So it kind of follows that strictifying your entire project provides stronger guarantees. I mean, part of it's linear. Now all the code in your entire project is analyzed by the type checker. But part of it is also that you now know that all of your dependencies aren't feeding you any's. So you can't be getting basically suppressed errors because you're calling a dependency that, oh my gosh, I'm sorry. You can't, you're calling into some dependency that was not well typed, and therefore you're getting an any from there that's suppressing errors within your module. That said, poorly typed third-party libraries or dependencies or things you don't control could still inject any's into your project. So that's kind of third-party boundaries are kind of where problems could still lie. So what now? All right, so enter type stubs. So we know that even in a fully typed strict project, any's can still flow in from dependencies that you don't own, and maybe you own them, but you can't type them like Python code. So stub files are one way to address this. Basically, stub files are a public interface of type signatures that override the implementation logic of that module. So you can kind of create a stub file. It can live right next to the file in question that it's annotating, or you could have a whole directory of stubs that you just import in and add it to your configuration, and Pyre will know about it. TypeShed is a sort of open sourced collection of built-in stubs, commonly used libraries. Like all of these already come with stubs, and they come pre-bundled in with the type checker, basically any type checker you use. So you may have noticed that all of the standard library functions we were calling were already well typed, and that's because those types are defined in TypeShed. It is a GitHub project you can play around with, but those are all bundled in with the type checker, and we already know about that. And then just as an FYI, in case anyone is surprised, type annotations have been around for enough time that actually most commonly used libraries, like the top 100, I think was what we looked at. The majority of these do come with types. We even have a PEP that specifies a way to bundle and distribute type information as a package. So chances are, if you're using a library heavily and you want those types, you can find them. They exist for most commonly used libraries. So hopefully we have a somewhat decent understanding of how to approach typing a large code base. Any questions before I keep going? OK, we'll power through. I think we're almost done. The final question that we might want to answer is, what if I have very dynamic code? Maybe I'm generating a bunch of classes on the fly, and they have variable names, and there's no way I can statically know what they are. Or other legacy code that I just don't want to refactor. But I still want the benefits of type checking on the rest of my project. So we'll kind of get into how to express more dynamic patterns that you might think fall under this category, but actually are expressible in the type system in the next section. But let's assume that you really can't deal with it right now. So we have some escape hatches to accommodate these cases. We've already seen the any type. It's often implicitly used when annotations are missing, but you can also use it manually to just tell the type checker, I know you have a type guess for this, but I want you to treat it as any, and not error against it for the rest of the control flow, no matter where it's passed. We also have type casting. So if you maybe know that the type of this value is something more specific or different from what the type checker thinks, maybe because of some side effect or some other weird condition, you can just tell the type checker, trust me, it's an int. Don't ask any questions, and it'll be an int from now on. You have to be careful, because if you're wrong, then the type checker is just going to lie at you later on. But that is an option. And then finally, if maybe you don't want to cast this whole thing as any and have it ignore errors against this value forever, you just want this one assignment to stop complaining. You can use an inline suppression to just shut up the type checker in the moment. And finally, you can kind of use stubs as type casting at scale, right? Because we're overriding the whole interface of a module, essentially casting. And we also have error suppressions at scale, which we'll talk about next. In some really tricky cases, we also support stubs that basically tell you anything, any name, whatever gibberish you want, you can import from this module, and the type checker won't complain about it and just treat it as any. So that's what a placeholder stub is. It's not super often needed, but if you have questions about it, feel free to ask. All right, so let's quickly review. We've seen all of these already. There's strict mode. This is usually the goal. It's where we stop introducing implicit any's, and we get some stronger guarantees the more modules you have. If you have high value code or sensitive code, or maybe hot modules that a lot of things depend on, usually you probably want to get it to strict as quickly as you can. We've seen gradual typing, so this is the default mode for type checking. And all annotations are optional, and it kind of smooths out the process for onboarding. And then finally, I mentioned earlier, if you want suppression at scale, you can just tell the type checker, just don't error on anything in this file. I don't care. And so that is also a type checking mode. So we often use these along with continuous integration to sort of lock in all the forward progress that we make and prevent any backsliding as we gradually migrate sort of a large existing poorly typed code base one step at a time at whatever pace makes sense for us. All right, so this is the initial set of challenges and some of the approaches that we've talked about to sort of address each of them. I won't read them to you, but with this combination of approaches, at least we have had a really good experience driving Instagram's millions of lines of code to over 99% type annotated over the last couple years, and that's without slowing down all the other things that are going on, other timelines or roadmaps, and without doing a huge overhaul upfront. And we've also, through this process, kind of found that a well-typed code base has been pretty invaluable for increasing development speed, reducing the number of crashes that take down the site or actually result in what we call a SEV, like a production problem. Building smarter code mod tooling and linting, and also detecting privacy and security issues at scale without having to do security reviews of, well, we also do that, but in addition to doing security reviews line by line manually. So those are just some of the applications we found as we went through this journey of converting a huge untyped code base to use types. And yeah, that's it. Any questions? Yeah, so actually, Pradeep is giving a talk on Saturday about one of the applications that a PEP just came out that we're using the type system, sort of leveraging it to enforce secure by default APIs to prevent like shell injection and other kinds of problems. So I highly recommend going to that if you're interested. But there are also other applications just based on the semantic understanding that the type checker has of the code. We've built a taint analysis tool on top of our type checker. It shares the same backend that basically tracks data flow through code and looks for bad data usage or like user controlled data flowing somewhere it shouldn't, things like that. We've also used, I could talk about it more. Yeah.
Extend these types to like flag certain types as like, oh, this is a data of this level, whatever, and then if it's entering regions of the code that widely accessible or something, then you can have some tooling that will flag those regions where it's doing.
Yeah. So either you can represent that kind of sensitive data directly as a type, or you can use the type knowledge to basically build a really accurate call graph of like your whole code base. And that enables a lot of other static analysis that's very similar, I guess, in concept to type checking, that like models that data and checks it. And so we actually employ that to catch a lot of security vulnerabilities before they land. All right, I think I am at time. Gia is going to talk about, basically spend the rest of the tutorial getting into like interesting Python patterns and how to express them in the type system. I'll pass it off. If you want to come get the mic.
Ping, test. Does this work? Hello, test.
How about we do this?
Ping, test, ABC, right? Okay, cool. All right. So I'm Gia. I'm going to tell you about typing common programming patterns. I hope that at this point, you're all familiar with the basics of typing. This section will mostly focus on the trickier cases, and it will take you through some of the more advanced utilities you're going to find in the typing module. Content in this section are mostly focused on the type system itself. It's not tooling specific. Like most of what I'm going to tell you is going to be generalizable for most type checkers. This is also designed to be a mixed session of me presenting and you doing exercise. I'm going to be talking for a while, and then we're going to do some simple exercise for practice, and then I'll come back and keep talking, and then we'll do exercise, rinse and repeat. It's kind of difficult to estimate how long the exercise is going to take, so I provided extra amount of content in the slides just in case we're blasting through all the exercises, but on the other hand, it may also happen that we spend some extra time with some of the exercises and won't have enough time to go over all the prepared contents. That is totally expected. If that happens, no big deal. Slide for the remaining contents are there online, so you can check them out at your leisure later as well. So whenever you see this icon, that means that I'm done talking and it's exercise time. All the exercises in this section is located as the typing pattern exercises subdirectory in the GitHub repository, which is cloned in the previous section. Please cd into this directory right now in case you forget it later. They are grouped by topics. Each file is pretty self-contained. Exercises can either be done locally, where you just cd into the most specific directory and run Pyre check to verify answer there, or you can follow this short URL where I provide Pyre playground links so that you can do them online in case your setup or your installation has some problem and you still want to follow along with all the examples that I have here. During the talk, I plan to go through only a subset of all the provided exercises. Those are not covered will be considered take-home exercises where you can just do them offline if you're really into them. Okay, so this section, I'm going to organize it into 3 topics. The first topic is about how to work with functions that deal with more than one type of values. The next is about issues you might run into when working with classes. And finally, we'll consider how one could type functions that operate on other functions. The first two topics, I think I have enough time to cover live today. The third topic is likely going to be the bonus part of this talk, where we may or may not skip it or stop in the middle, depending on how much time is left at that point. Okay. So first, how to work with functions that handles multiple values, handle values of multiple types. I'll talk about three techniques that can be used to annotate these kind of functions: unions, generic functions, and overloads. Let's start with the simplest technique, the union type. In previous section, we have gone through a lot of examples and exercises on functions that are relatively simple like this. Parameter types can be uniquely determined. Return type can be uniquely determined. There's no doubt and no ambiguities on what this function operates on and what the function produces as a result. But not all functions are written like that, especially in Python, which is a very flexible language. You would run into functions that works on more than one data types. For example, we have a function here that tries to send a piece of data to the network. Its behavior depends on the argument data we pass to it. If the data contains raw bytes, we forward the data directly to a lower level API. But if the data contains string, what we do is that we encode the string first into bytes and then send it through. Sending any other types of data will be considered a runtime error. Now the question here is like, what type annotation should we give to this argument data here? We can't just say it's a bytes. We can't just say it's string. We need a way of saying that it's either a byte or a string. And to represent that kind of or relation, we need to use a union. Here's how you use a union. Before Python 3.10, this is what you do: import the name union from the typing module, and then you use union square bracket to enclose all possible types and use that as the annotation, as we've shown here. If you are on the most recent Python release, then there's a syntactical shortcut you can take. You no longer have to import anything. Just use this vertical bar here to separate the possibilities. So I can just say my data is a string or a byte. That means the same thing as union, string, or byte. It's just more compact and it's shorter. Regardless of what syntax you use to annotate the functions, the end result is going to be the same. The type checker will happily let you invoke the function with strings or bytes, but will point out anything else. They are not accepted. This is, should be pretty straightforward. We've seen an example where union types appear on the parameters. It turns out they could appear on the return position as well. Let's just do an exercise here to see if you can figure out how this works yourself. You can find this example in the subdirectory topic1/union/example0.py. To check locally, cd into topic1/union. Everything is set up there for you, so don't worry about running Pyre Init or anything like that. Just go to that directory, run Pyre check, and you're going to see the type checker outputs. Or you can go to this short URL to find the Pyre playground links, the relevant examples on the page. It is recommended to right-click on the Pyre playground links, to right-click on the playground links and open them in the new tab and keep a reference to this short page, because we're going to revisit that page later throughout this section. So let's dive into the exercise and see if you can figure out how to do this. Oh, if you're done, use a green sticky. If you run into problems, use red sticky, same protocol as we had before.
like, I didn't even know you could do this in Python. Line 5, these 3 dots here.
Oh.
Is that equivalent to what, like pass?
Yeah, it's like pass, don't care. Like,
Has that always been a thing?
yes, the runtime is gonna crash if you invoke that function, but
It won't run though.
it won't run. But it's just a way of like, for us quickly hacking examples for the type checker too. Yeah. Okay, I see a lot of green stickies. Is there any problems? Should we move on or? Good. Okay, for the sake of time, I think we need to move on. It should be a fairly straightforward example. This is the return type can either be a string or a bytes. The parameter type can either be a string or it can be none. It's also fine if you can do optional of string earlier in the talk. It means the same thing as string or none. Like these two function signatures are just equivalent to each other. Any questions on this exercise?
Ridiculous question, but if you're doing, union string or, or that, does the order there matter? Like, from like just from a developer usability, ridiculous question, but should I say nor string or string or not? Is it whichever is most frequent and we left most?
I think it's a most matter. The question is like, does the order matters for the annotation? The answer is it doesn't. You can just use whatever orders that you prefer. I think or none is like kind of a common pattern you see. So but really it depends on like your personal preference and what the rest of the team does. It's mostly a cosmetic concern. It doesn't really affect how the type checker consumes this annotation. So unions are great. It allows your function to handle values of many different types in a very simple way. But I also want to point out a caveat, which is not so obvious at first glance. You might have already noticed this in your exercise. The caveat is that unions forces its consumer to do a split. Remember this example that we had earlier. Here's on the parameter type. And inside the function body, where we want to consume that parameter, what do we do here? We use is-instance check to branch out the logic in the case-by-case basis. This is required for safety reasons. The encode method actually don't exist if your data is a byte. It only exists if your data is a string. So it is not safe to invoke the encode method always. So we need to do the case split to make the entire thing work. The same issue of union appear on some return type. If your function returns a union, then every single caller of your function that consumes your return value must also first check exactly which branch of your union the value belongs to. It is safe to pass data to a downstream function that expects a string only if we're sure that this data is actually a string. Same for bytes. But without doing this case split, we can't say for sure which is which. And as the function only hands us a union back. So This often makes your function kind of awkward to use because of the additional boilerplate that you have to write for whenever you want to consume it. But remember our intention when writing this function. If the encoding, then we don't do any decoding and return a bytes directly. But if the encoding is known, we decode the byte into a string. So in this particular case, the parameter type and the return type are correlated. We can sort of predict what the return type would be by just looking at the parameter. This kind of correlation is unfortunately not expressible with union types. We'll talk about what to do in next, but before we move to the section, any particular question about union types? Cool. On to the next topic. In this section, we'll talk about a technique that allows us to establish some simple correlation between parameters and return. Let's take a look at this example. We have a function here called process data. To make things simple, let's assume that all the processing we do here is just to log the data somewhere and return the data intact. So what we expect here is that when you pass this function a string, we get a string back. If you pass it a bytes, we get a bytes back. Pass it an int, we get an int back. Basically, whatever we pass into it, we get exactly the same thing back. How do we type annotate this function? Well, obviously, union is not the answer here. Say if we annotate this function with union, not only does it suffer from the same issue we mentioned before, that is, it can't really detect a correlation and will always give us a union back, which needs to be case split further downstream. The other issue is that this type annotation only works with these three types. It's not super extensible. If I say define a custom class myself and pass to it, the type checker is going to complain here. And this is definitely not our intention. This function should return whatever we pass into it. Another thing you might be thinking is, how about using the any type like this? Well, the type checker definitely won't complain no matter what you pass to the function if any is involved. The issue with this approach is that it completely destroys the type info we have on the return type, because all of them are going to be considered to have the any type. For example, if you try to invoke a method on the returned value and you made a typo, the type checker won't be able to help you catch this issue because, well, you have any there. We don't know exactly what methods are defined on there. Now, let's take a step back and look at this function again. Observe the properties of this function. First, the return types and parameter types are correlated. In fact, they're exactly the same in this particular case. Second, the function body works the same regardless of what the parameter type. When your function satisfies both properties, that would give you a strong hint that generics needs to be involved. Here's how you do generics. First, import this name called typevar from the typing module, and then define a typevar on the top level of your source file. There's one string parameter to this typevar constructor. That string is for runtime tooling only. It's not relevant to the type checker, but the convention there is that you should use the same name in the string as the name of the variable itself. In this case, you should just do t if your variable is called t. Now, annotate your function we just defined. Here, I'm using t as both the parameter and annotation. This means that this function takes any type as an input, and it will give us the same type back. If you annotate it like this, they are guaranteed. Then, like all of these things works. If you give it a string, we get a string. Give it a byte, we get a byte. If you have a custom class, no problem. We're gonna get that exact thing back again, right? So that is how generics and type works can be used. Let's see if we can put this into practice. Let's do some exercises this time. Let's do both of these examples and use the green sticky after you finish both of them. If you're doing the exercise locally, make sure you change your current working directory to /typevar. If you're doing exercise online, make sure to open the prior sandbox links in the new tab. And yeah, let's work on this. Are you guys doing okay? Need any help? No? True? Oh.
I'm really screwing this one up for some reason.
Okay. Yeah, the issue is that you're using the same var here, right? This means that the type of x and y's are the same.
Oh, so you have to have it separate.
Yes.
Oh, okay.
And the return here is also not a var. It's a tuple, right?
Okay. Perfect. All right. That makes sense.
Wait, what?
You both, right?
Wait, what?
Oh, the link says 0 and 1, so it's like first you use 0, then you do 1. And we're just waiting for them to do both.
Oh.
Is that?
Oh, yeah. Okay. Oh, okay.
Yeah, everything's good. Everything's great.
I'm scared.
It's going great.
Oops. Okay. Okay. Again, for the sake of time, let's move on. We have. Sorry. Keep going. Okay. Okay. I'll just post the answer here. We can talk more if you have further questions later. So for the first example, this should be what you get. We have two type vars, t and u here. X is type t, y is a type u, and the return is a tuple of t and u. It will also be interesting to exercise and explore what happens when you have like x and y both with the type var t and try to use t to annotate both arguments and try it offline to explore what this really implies. On this particular example, we have this function flatten list. I would do something like this. I declare a type var t, and I would say the input is a list of t. And the return is a list of t. Basically, all this function does is it just flattens the list. You give the list of lists, and we just flatten it and returns a plain list. This example just shows that type var do not have to they can appear nested in other types, especially container types. There is also some questions about the scope of this type var, like can we reuse it, or when can we reuse it, when can we not? I think I have a take-home exercise that tries to explore that. So yeah, again, if you're interested, you can explore that later offline. And two minor things about type var before we move on. The first is that type var are typically defined on the top level of your module. In other words, you might want to avoid define type vars inside the function or inside the class. Type checkers typically don't want to look for type vars there, so just to make it easy for everyone, please define them on the top without any indentation. The other thing I want to point out is that type var is a tool to establish correlation. If there's no correlation at all, then there's no point in using it. For example, here we have a function where the type var only appears on the parameter. The return, it does not appear on the return, and no correlation is established. Now, such kind of usage of type var is legit. The type checker is going to accept that, but we have a much simpler and much straightforward alternative. Just annotate the data as object. These two function signatures means exactly the same thing. They mean whatever type the data is, my function can take it. Objects here, because Python, everything is an object, so saying that my data is an object is the same as saying anything goes here. The second one is simpler, and it does not need to involve any type var. What's the difference between? Same thing. I'm just saying that this one is shorter. Okay, the question is, what's the difference between object and any? Any is not part of the type system, and object is. The thing, in other words, if you have a variable or a parameter of type any, you can access whatever you want. Like, any is considered to have all the attributes. Like, you can access random things on that object. Type checker won't complain. The same is not true for object. You can only access attributes that are defined on objects. That's one thing. And another thing is, like, if you have a function that takes any as argument, then you can pass anything into it. But if you have a function that takes, if you have a function that takes, for example, int as an argument, and you pass it to an any, there's no problem with that. Like, any is compatible with int, but if you have an object and you want to pass that to that function that expects you to take int, then that doesn't work, because object is not an int. So object is like a kind of a superclass of everything, while any is like both a superclass and a subclass. It's just it's hash we're going to have in the type system. Other questions? That's all about type var. Type var gives a way to establish parameter and return types. But in practice, there are tons of cases where that correlation is not really that simple. In fact, let's go back to our early example we had about the receive data function. Here's the function body again. The expected typing behavior is this. If we give it then return type is byte. If you give it a string, the return is a string, right? We've already talked about why unions is not the best way to annotate this. If you annotate the function with a union, what you give it, you're always gonna get union back. This is not what we want. We also can't do it with a type var here. Say if I annotate my function like this, then if you give it a string, get string back. If you give it a none, you're gonna get none back, but we want here to be bytes. So this is not what we want. Again, the issue here is that the association between the parameter type and the return type is not that straightforward. Like, you can't express the relations between the parameter and the return in the simple rules, like the parameters and returns are the same. Like, these mappings are kind of ad hoc. What you have here is a function that sort of like this, where if you pass this function type A, you're going to get back B. If you pass it type C, you're going to get type D. Otherwise, you're going to have to get type E. So, and A, B, C, D, E here can be arbitrary types that are completely unrelated to each other. So what would you do in those cases when your function behaves like this? In that case, I would say that overload is what you should be looking at. Overload means that the word overloading just means to create multiple functions of the same name with different type signature. The way you do it in Python is to first import the name overload from the typing module. And then you provide your list of ad hoc mappings by writing a series of function signatures, and each decorated with this overload decorator. The idea is that every single signature here describes one parameter return mapping. So what I wrote here basically means if my receive data receives no argument, or if it receives argument of type none, then my return type will be byte. If I receive a string, my return type will be string. The Python runtime does not really care about this overload at all. From the perspective of the runtime, overload, these steps are here only for the type checker to consume. This also means that if you have an actual implementation of the overload, you better keep it as well. Otherwise, the runtime will not be able to figure out how to run your. It is recommended to annotate your implementation function with union-based fallback annotations. This is because some type checkers in the past, they do not support overload, so they want at least they want something. When they want something, otherwise they don't know how to type check this function. But Pyre does support overload, but I think we still forces the existence of these fallback functions, just because, again, we don't want you to leave no annotations here and let the type checker skip it, because there might be type errors hidden in it. Right? If you provide this whole set of overloads, then we get all we want. We can, from the caller side, we can send all those arguments, and we're going to get the right corresponding return type back. Okay? That is how the overloads works. Take a look at this exercise and see if you can put this in practice. Again, if you're doing this exercises locally, make sure you change your current directory to this topic1/overload directory. And if you're doing this online, open the sandbox link, open the Pyre playground link, a new tab, so you keep around reference to this page. If you want it. Oh, you can't describe this with generics, right? How would you just use generic to type this? The thing is, like, the mappings are all ad hoc. They can be random. Like, they don't have to be the same. Like, you say this is a string and this must be a string. Do you need any help, or we're good? No, I'm just checking. this section too.
No problem.
All right, cool. Did that help? This one. At runtime, all type annotations are ignored, so runtime, no performance penalty. This one is more complicated for a type checker to handle, but I mean, it's generally fine. There is very rare case where like the type checker is going to struggle with that, but that's probably the type checker needs fixing.
So it really probably just comes down to how many permutations you're trying to do, right? If you want them, because the overload lets you be more strict with the typing.
It's more, yeah. It's also more easier to use as a caller, right? So if you're a caller, you don't want to get a union if you know exactly what branch of that union.
A discrete set of types that are going to be used. I'd rather have that than a union, which is less strict.
Yeah. Are you doing okay? Or I need help? Okay, cool. Okay, let's move on. I think our exercise should be very similar to the example I had before. This is what I would do. If n digit is non-existent, or if n digit is a none, we get an int back. If n digit is an int, we get a float back. I think Pyre also forces you to use fallback annotations, so I'm just going to do this on my implementation. This is like how I would type annotate this example. Okay. Overload is no doubt a very powerful tool. Many people like its flexibility because it pretty much allows you to establish arbitrary form of correlations between the input and output types. Sometimes those same correlations, they just cannot, there's no way you can express them with generics or with the unions. But at the same time, this is a very complicated feature. It is fairly syntactically heavy. You have to write a lot of additional signatures to convey your meaning to the type checker. You may run into ambiguities if your overloads are not written carefully, plus the fact that type checker may not be able to precisely type check the body of the actual implementation with the fallback annotations. In one of the take-home exercises, I'll try to hint on how you can refactor your code so you can sort of avoid the need of using overload in your project. But that only happens if you control the whole project. If the overloads come from a third-party library, then you're stuck with it. Okay, now we conclude the entire first topic. Takeaways are unions, type vars, and overloads can all be used to annotate functions that work with values of multiple types. Use union type in the case where you need a case split. Use generics when the parameter types and the return types, they're simply correlated. And use overload in any other case where the other two is not expressible enough. Right? All right, on to the second topic today. In the previous section, all we talked about are functions. In the next section, we're going to shift gears and move from functions to classes. There are still multiple subtopics I want to cover here. The previous section is more about my function, how do I type annotated. In contrast, this section is more about, here are some of the safety net that type checker tries to cast. what are the rationales behind them. This is also reflected in our exercises. They will be more about reading and understanding the surrounding context and less about going ahead and trying to solve puzzles. As a maintainer of Pyre, we interact with Python engineers coming from other teams within Meta a lot. They often ask us why Pyre complains about certain things, and they're looking for suggestions on how do we fix this. And it just so happens that a lot of those questions are related to classes. So I figured it would be really useful if we can share those relevant knowledge to a wider audience. The first subtopic is inheritance and overload. I presume that everyone here all have basic knowledge on how that works in Python. Here is an exercise that jogs your memory about all these stuffs. Please take a look at this example. Again, make sure to change your current working directory and open up the links in the new tab. This is a very simple and straightforward exercise. It's more about reading than about figuring out what to do. So please take some time. I don't think I'm gonna finish everything.
Yeah.
Maybe I'll just cut topics or.
I really like the list cop substitution style. I feel like that's, I don't know, really meaningful to get out. So if there is stuff earlier, like maybe you can just say, we'll just show you the answer without, I don't know if that ends up getting you there, but.
I can't do this here because the code is all, I don't have all the code, but I can probably do it with the container, but I'm not sure if we're even gonna get that far. Maybe I'll skip the protocol. I think that's what I'm gonna do, skip protocols and go directly to containers.
Can you quickly mention, like, this is a protocol, it lets you, like, one sentence describe again, and then just.
Well, but then, yeah, I won't avoid that, right?
I'm sorry, I ran over.
Oh, but yeah, it's totally fine. Okay. All right, so this should be a very simple exercise. I can type annotate my function, pet1 are all of the parent class pet. And if someone else tries to invoke my function, they do not really pass me object of class pet. Subclass objects are completely fine. They can pass me, for example, dogs and cats, but they cannot pass me irrelevant classes like int or string. As we've seen this example in the object-oriented programming world, inheritance and overloading is actually the idiomatic way of making your function operate on multiple type of values. In this example, note that I did not use unions anywhere. I did not use any case split, is instance, none of that stuff. Yet my befriend function is still able to behave polymorphically thanks to all the implicit branching that all the dynamic dispatching and subclassing gives us. This is the beauty of object-oriented programming. Although subclassing and method overriding is awesome, although they allow us to craft all those beautiful design patterns, they're not always safe to do, as shown in our example. We saw in the example that the duck class override the play with method such that it takes no argument. If we run the code like this, it's gonna crash at runtime. The point here is that it's not really safe to override a method in the subclass arbitrarily. There are rules that we need to follow, otherwise we might run into, like, a program can easily break at runtime. So the question is, what exactly is the rule? A pioneering scientist, Barbara Liskov, had nailed down such a rule for us when studying the problem of data abstraction. We call this rule the Liskov substitution principle. I really want to have the picture of Barbara Liskov here, but I was told I can't because of some legal concerns, so I'm gonna just put my pictures up there as a placeholder. This is not the original statement of the substitution principle. It's less rigorous, but I hope that this can get the idea across. The principle just says that the subclass can do more than what the superclass do, but they cannot do less. This should be intuitive since the type check in the type system allows us to pass objects of the subclasses to functions that operates them as superclasses. Now, if we expect the superclass to provide certain interfaces and the subclass does not provide them, then it does not really make sense for the type system to allow you to treat subclasses as superclasses, right? All the substitution principle is saying is that the type system should be consistent in terms of how it handles subclassing. Going back to our example, what the parent class pet can do is to be invoked with the playwith method with one argument. So whenever we define a subclass, it's always okay if we just keep the type signature. But if we don't follow the substitution principle, if we define a playwith method that does not take a number of arguments, that would be problematic. The superclass that a behavior duck cannot fulfill. So that is definitely going to get us into trouble in the runtime in certain cases. Thankfully, most type checker will help us enforce the substitution principle. So if you actually do this, the type checker is going to warn you. And this is actually a good thing, because if the type checker do not complain, you would risk your program crashing in runtime. Let's look at another example. Now we have a clone method defined in the pet class whose return type is pet. According to what I said before, it should be okay if you override this method, another method that have the same signature. Now here is my question. Is it okay if I override this method and change the return type from pet to dog, where dog is a subclass of pet? Is this okay? Although the superclass required the function to return a pet, and we are returning a dog here, a dog is a pet, so we're like fulfilling the contract of the superclass, so this is okay. But it's not okay to change the number of the argument, or if we change the type of argument to something that's incompatible. Another example, we have a likes method defined where it takes pet as an argument and returns a bool. Again, if you keep the type signature intact, this is okay. If you change the number of the argument, or if you change the types to an incompatible one, those are all type errors. Here is another question. Is it okay if I change the type of the other from cats to pet? Sorry, from pets to cat. It is not, right? The issue here is that the pet superclass pet expect that the likes method to handle any kind of pet. But in our subclass, we can only handle objects of cats. This is only one kind of pet. Other kind of pet cannot be handled by this function, right? So our subclass has something, there's something that the superclass can do, but the subclass cannot. The substitution principle is broken, the subtyping doesn't hold. This is problematic, we need to change this. It's okay if we do it the other way around. If the superclass says I expect a cat, and if you override it such that it takes a pet, that is absolutely fine. If you can't handle any pets, then you can definitely handle cats. So this will be accepted by the type checker. The general rule of thumb here is that in your overriding method, return types can always be more specific, and parameter types can always be made more general. But the other way around is not okay. You can't make the return type more general, and you can't make the parameter type more specific. These are all corollaries from the substitution principle. Okay, that is all I want to say about classes. I think I'm going to skip one topic and jump directly to containers for the sake of time. I do want to say something about containers because they get used a lot, so I figured, it's definitely going to be used more often than the protocols, so here it is. There are 5 built-in containers in the Python standard library, tuple, elliptic set, and frozen set. If you write Python a lot, you should be really familiar with this. What you might not be familiar with is how to write type annotations with these containers. Prior to Python 3.9, you have to import these capitalized names from the typing module and annotate your containers like this. But after 3.9, you can finally use these non-capitalized names, and you no longer have to import anything. That is why all of these works in our examples we see in the previous section of this talk. Untitled Python allows containers to be heterogeneous, meaning that you can put any kind of garbage in your container, regardless of whether they're of the same type or not. This makes it super hard to reason about your code in the general case. Other people may need to keep track of exactly which index hold which kind of value. This really makes their code a bit harder to understand because you have to keep some extra information in your mind. The type system, on the other hand, will not allow this. If you say of int, you can't put a string into it. If you really want to do this, then what you can do here is you can say, I have a list of int or string, or I have a list of a superclass, like a list of object. This is fine, but in exchange for that, it will make your life a little bit harder when you take things out from the container. If your container is a list of int or string, and when you take something back, you don't know exactly whether you get an int or string. You have to use is-instance to do case splitting further down when you consume this. If you really want your list to be heterogeneous and you're absolutely sure that, hey, the first element in my list is an int, the second is a string, they're all fixed, then I would argue that you're not actually looking for a list. You're actually looking for a tuple. Tuple allows this element to be heterogeneous. It can have any number of types within the square bracket. The numbers would be the same as the length of the tuple. For example, here I have a tuple that consists of an int and a pet. Annotation of my tuple would be this, right? If you take things out, it does what you would expect. If you have an arbitrary integer where we don't know what it is, you get a union of all these.
Is there some syntax for first element is of this type, and then every element thereafter is of type whatever?
I don't think you can do that, but what you can do is like you can have a tuple of 2 elements. The first one is known, the second one is a list, and then you basically could change the structure of your data a bit. Tuple annotated this way always need to have a fixed and finite length, but there's another syntax with a tuple where you can have tuple of arbitrary length, but in exchange for that, you give up heterogeneity. This just means that your tuple only contains int. You can have any number of ints in your tuple. It's like a list of int, but we're still dealing with tuple here. Similar to list, keys and values the index cannot be heterogeneous. They must all conform to the same type. You cannot just map some keys to some type and map other keys to other type. Again, use the union or object if you want if you do want to allow these, with the caveat that things are going to be a little bit harder when you take them back, when you take them out of the container. The final point I think really worth paying attention to is the mutabilities of the container. Some containers like list are mutable, meaning that it is allowed to add new things into the list or change existing elements in the list or remove elements from the list. Other containers like dict and set also behave like this. Some other containers are immutable, meaning that you can do none of these things. Like frozen set is also an example of this. The way of looking at this is that if we have a tuple and we invoke some function on this tuple, and when the function returns, we're guaranteed that we're going to get the same tuple back. But if you do this with a list, that's not always guaranteed because some function may mutate your x inside it. This property about mutability has some interesting implication to type checking. For the sake of time, we'll just skip this exercise. I'm just going to put all the examples here. We have a small class hierarchy where the base class is pet. We have 2 subclass dogs and cat. A cat can meow, a dog can't. That's just fact. We have a function called processPet, which takes a list of pet as its argument. And then here we have a list of cat here. And we pass this list of cat to this processPet function. And then we just expect we get a bunch of cats out. Now, everything looks reasonable in isolation, but there's a type error and there's a legit runtime error that's hidden somewhere. in this setup. The issue here is that your process pet function can actually mutate this list. For example, it may put a dog into your list so that when this function returns, you're no longer getting a list of cats, but you're going to get a list of mixed cats and dogs. And the dog can't meow, so you're going to get an error here. Issues like this are really subtle and really hard to detect in practice. But if you're using a type checker, it is going to tell you, it is going to warn you that when you do this, there's some problem. Now, the error message here is a little bit unintuitive at first glance. If cat is a subclass of pet, then why is list of cat not a subclass of list of pet? The reason lies in the fact that a list is a mutable container. Think of it this way. A list of a cat allows arbitrary pet to be added into it. But a list of cat only allows arbitrary cats to be added into it. It does not support adding arbitrary pets into itself. So there's something that the list of pet can do, but the list of cat cannot. So substitution principle doesn't hold, so this is not OK to do. On the other hand, if we're using an immutable container like a tuple or a frozen set, things become different. We don't have any mutation to worry about. So it's OK to say that to pass a list of cats to a functions that, it's OK to pass tuples of cats to functions that expects tuple of pets. Now, what if we know that our process function never changed the input list? What if I want to perform non-mutating operations? I just don't want to perform non-mutating operation inside this process function. I promise I will not change this list. Is there any way to do it without changing my cats to be a tuple of cats? What you need to do here is to annotate pets with a type called sequence. Sequence is a superclass of list. It's just a list without all the mutation operations. You can't do pop, you can't do append, you can't write into any elements into a sequence. This way, you're going to type checker, hey, I promise I won't change anything in this function body. It's going to accept this. It's going to say, OK, fine, you can't pass a sequence of cat to a sequence of pet because of immutability here. If we somehow broke that promise, the type checker is as well, so things are all fine. For lists, we can have sequence as its immutable, the immutable version of it. For dict, we have mapping as the immutable version of it, and for set, we have abstract set as an immutable version of it. We also have iterable, which works for list, for cat, and for dict. But iterable supports less operations. Like you can only literally just iterate your container without doing anything else. You can't index into it. You can't do anything of that. And before Python 3.9, you can import from typing all these names. After 3.9, these names are all available from collection.abc. Okay? That concludes our second topic. And I think for the sake of time, that should also conclude the entire talk. I'm sorry I didn't cover everything here. Again, the uncovered contents will be in the slides, and you can check them out offline. Yeah, that's it. We made it. This concludes the entire tutorial. Thank you so much for joining. We really appreciate your time and your attention. And all the speakers today will be here for all the PyCon. So if you have feedbacks or just want to follow up or you want to chat or have some questions, just come and find us. Yeah. Alex, if you want.
Hello, and then if you just spend just 1 quick minute filling out this short survey, it's fully anonymous, it'll take you a minute, you can open it in an incognito tab, it'll help us improve this talk and know what we did well and what we can improve on. Thank you very much.